I was supposed to be recording this. I forgot. Um, is everyone happy to take a shot at this one now? I'm going to take that as yes. And may I have a volunteer?
Yeah, I don't mind solving this.
Thank you. Yeah.
What I did was I assumed the side length of the square was x, which means the total area is just x squared. And because the semicircular piece is cut out, that's like, oh, obviously that's half a circle. So the area of a circle in terms of its diameter is pi d squared over 4. And in case the diameter is x, so it's pi x squared over 4. But because it's a semicircle, I multiply that by half. So it's pi x squared over 8. So I ended up getting x squared minus pi x squared over 8 is equal to 100, which is the area of the remaining metal. So I just multiplied everything by 8 to get rid of the fraction. So I got 8x squared minus pi x squared is equal to 800. And then I factorize x squared out of it because we want to find the length. So just getting x on its own. So I got x squared is equal to 800 over 8 minus pi. So x is the square root of 800 over 8 minus pi. And obviously that simplifies to 400 times 2, which is 20 root 2 minus 8 pi. So I think it should be A.
Yeah, well done. Good. That's exactly what I got. Perfect. Which of the following is a correct expression? Oh, they've given yeah, they've given exactly the same thing you did, but yeah, well done. I didn't realize they'd given answers to that one. A right angle triangle, and then yeah, can you guys take a shot of this one? So, is someone happy to go through the solution?
I can go through it.
Yes, please.
So it's half of the horizontal times the vertical sides. So if you just like expand them out, you get 8 minus 2 root 2 minus 2, which is then 6 minus 2 root 2, and then you half it, so it's just 3 minus root 2, which is b.
Beautiful. Well done. Yeah, they say exactly what you said. Well done. This one. Yeah, see, they don't go through solutions for all of them, which is very strange. And then can we take another shot at this one? Is everyone happy to go through this? Great. And then is anyone willing to go through? Anyone willing to volunteer?
I could.
You can.
So first I cancelled out the x from the top, and the x squared became x at the denominator. So that became 4 minus 3x plus 1 by x times 3x squared minus 2x minus 1. And the 3x squared minus 2x minus 1 simplifies to 3x plus 1 times x minus 1. So then you cancel out the 3x plus 1, so you get 4 minus 1 by x times x minus 1. If you multiply the 4 by x squared minus x, that's what the denominator is. If you expand it, you get 4x squared minus 4x minus 1 by x times x minus 1.
Yeah,
So
well done. Really good. And then just key thing to note for anyone else that didn't, simplifying earlier in this case made it a lot easier than if you tried to do the 4 times x squared, 3x squared minus 2x minus 1. It saves you a lot of time rather than having to deal with all the quadratics and then cancelling stuff down later. So yeah, just another time saving one. Where also a good one to notice is a lot of the quadratics they give you, where you've got ax squared plus bx plus c, your a will often be a prime number, such as 2 or 3 most commonly. So it becomes quite easy to then see where the factorization occurs, because you know you're going to have like a 3x plus something and a x plus something. And in this case, you can see this 3 here, so you know it's going to be 3x plus something, and you can see 3x here. So it should give you a clue that it's going to cancel out near the start and that you won't need to multiply this by this, but you should notice that this should be able to disappear right at the beginning. But yeah, well done. And this one, okay, yeah, they do have an answer for this one. So can you guys all take a stab at this one? Yeah. Is anyone willing to go through their solution? If you're all done.
Sure. So I did 1/6 times the probability for the unfair dice is 1/18. So the probability for getting a 6 on the unfair one is 1/3. And then 1 minus a third is 2/3. Then divide that by 5 because the other 5 are all equal is 2/15. Then 2/15 times 6 is 1/45.
Really good, yeah. Well done. Only thing on this question is if they'd asked for different numbers, because there's only one way of getting a 2 and one way of getting a 6. You don't have any sort of other multipliers about. But if they'd, for example, chosen to do a 7, where it could be a 6 and a 1, a 5 and a 2, a 4 and a 3, then there would be some binomial stuff coming into it, because I'd imagine like you'd have like 4 choose 3, for example, or would be 6 to 12. But yeah, they've been I don't think they'd give you anything too much hard on this, because they're not expecting you to remember Pascal's triangle or anything you need for binomials. So yeah, it is just exactly as you said. The 1/6 times 1/3 and everything like that, without having to worry about any coefficients. But just so you're aware, it's like more in-depth side of the problem. Good. And then they tell you exactly what you just told us. So well done. That is everything they've got for the presentation going through Maths 1. It's supposed to be okay. We've gone through this rapidly. I suppose we did start 15 minutes early as well. It was supposed to be, I believe, an hour lunch break at the end of that. What I am happy to do is, if you've got any questions that you've done in practice, whether you're doing ENGA, NSAA papers or anything like that, and people want to ask me about them, or if they couldn't understand the solution that was given or couldn't understand the answer, I'm happy to go do a few questions now, just like, maybe up until 10 past 12-ish, so probably about half an hour. Also, I will say if there's any issues, if you do want me to take a look at any questions and I can't solve them on the spot right now, I am happy to go away and do it in my own time if you leave me your email address and said question, and then I can just email you the solution later. But yeah, I'll say take a 5-minute break for now, because I will go through and do that one at the very start. That one at the very start, which there was a bit of confusion, the bakery, was it? Yeah, I'll do this one quickly. And if in that time you want to find any questions you want to ask me about, and then we can do that. Also, very quickly, actually, just before I do that, is there any questions anyone wants to ask in general, whether related to the exam or anything we've been through so far?
Yeah, I had a bit of a question because I noticed in some of like the NSA and ENGA practice papers, there were binomial expansion questions, but like obviously you can't have your calculator, so do you just use Pascal's triangle to work out the coefficient?
The binomial ones in question, were they much higher than like to the 4 or anything like that?
Yeah, some of them were like 5 or 6, but that was the highest I think I saw.
Okay, I haven't come across those, but yeah, that is quite brutal. Yeah, I would say go for Pascal's triangle if you need coefficients for that. That's probably the easiest, because up to cubic, 1, 3, 3, 1. And from that you can get the rest, because then it would be like 1, 4, 6, 4, 1, and you can work from down there. So yeah, I would use Pascal's triangle for any binomial that you need to do if you're not allowed to calculate it. That I'm sorry if you've seen them, that's cool of them. I haven't seen any personally, so I think they're semi-rare, so hopefully it doesn't come up. But
Okay.
yeah, use Pascal's triangle for those.
Cool, thank you.
Yeah, sorry, I had a question as well. So in terms of, because I've been doing the ESAT mock papers on the website, ESAT practice questions. So how do we know like what's representative? Like how, like, is it really representative of the actual difficulty of the ESAT? I mean, it's got to be hard to predict, right? So what would you recommend in terms of, doing questions which represent the ESAT difficulty? Because some questions, it's like a variety of difficulty, and some questions, I think as mentioned before, were not in the spec.
Yeah,
So
so the best one that I can say to gauge difficulty is do the specimen paper. So on the ESAT website, they've got the specimen paper and the practice papers, which follow, both of them follow the test format. But the main thing is the practice papers. They've just those questions are just stolen from ENGA and NSAA, I think, because I did the Maths 1 practice paper and I recognized a few of the questions. So yeah, the best one to gauge the difficulty of the ESAT specifically, the only way I can say you can really do that truly is the specimen paper. Because I think that's just like they've made 2 ESATs, one's the official test and one's the specimen. So take the specimen ones as examples of actual difficulty. I would recommend doing the specimen paper in the next 2 or 3 days, because that gives you about a week before the exam. So you should know exactly how difficult it is. And then to get an idea of timings and stuff. I imagine the ENGA papers are going to be very, very similar to the ESAT difficulty, just because they are also a minute and a half per question. Particularly look at part 1 of the ENGA. I think part 2's slightly different and more difficult. So if you go on the ESAT website, when it does practice material, I think it only does the ENGA part 1, because that'll be most reflective of what's in the ESAT. So yeah, that's my best advice, I'm afraid, for gauging difficulty. The specimen paper is your best bet, and then the ENGA is kind of close.
thank you.
Sorry, I had a question about the interview which you did. So for the interview, I saw like this example interview on YouTube for engineering. For the interview that you did, did they sit you down with your personal statement and like ask a bunch of questions about your personal statement as well?
Yes, they do ask you about your personal statement. So on mine, I said I'd read a certain book, and they said, "Oh, what did you enjoy about this book? What did you learn from it?" Stuff like that. Basically, I'd kind of prove I'd read it. I also mentioned I'd done a quantum physics course, and they were like, "What was your favorite part about that?" So they asked those sort of questions. They won't, if you're like, I don't think they'll try and catch you out, especially if you're honest. So for example, they're in the quantum physics one, in the quantum physics course I did it at the end of year 12. It obviously been like 7 months since I'd done the course, but during the course we learned about how to mathematically derive the orbit of an electron about an atom. And then I found that really cool at the time. I put it in my personal statement, and they were like, "What did you find cool about the orbit atom? Can you still derive it?" And I just went, "I really enjoyed it at the time. I cannot remember for the life of me." And they were like, "That's fine, don't worry."
Okay. Yeah.
So yeah, but they will ask you about your personal statement. If it looks like you've outright lied or anything like that, obviously they will catch it. I remember they asked me there was a couple sentences I put in there that I thought no one would take a second look at. And then I put some stuff to kind of like almost invite a question, which they didn't. They didn't ask me about the stuff I was expecting them to ask me about. And then the stuff that I thought no one would glance at again, that was the stuff they're coming at me for. So they probably will catch you out on it. So just make sure that you're truthful in it, or at least that you've caught up to your personal statement. I know the classic, you say you've read a book, you haven't read a book, and then you read it the day before your interview. As long as you do that, you should be fine. But yeah, they will ask you about your personal statement. It's not a huge part of the interview typically. Most of it will focus on technical questions or engineering related questions that aren't to do with your personal statement. So
I also wanted to know, I heard that after you've applied, you'll get something like a My Cambridge like application or portal. I don't know what it is, to be completely honest, where you can add another personal statement. Is that where you also need to choose your second choice and third choice colleges if you're applying Cambridge?
I'm going to be honest, I have not heard anything about that, and it's not something I did. I only remember choosing one college. I don't remember applying to having like a third or fourth choice. My typical understanding is if you are a strong applicant, but the college you want doesn't take you, they pull you, and then some other college will say, actually, he looks quite good and we've got a little bit of space, we'll take him, to my awareness. I'm not aware of a second and third choice unless the system has changed, because I did my interview in 2018. Yes, yeah, because I finished A-levels in 2019. So I did my interview in 2018. So if it's changed in the last 6 years, then maybe that's where you've heard that from. But that wasn't something in my experience. I have heard the thing where you can give like an additional personal statement directly to Cambridge. I did not. I just used one personal statement for everyone. It's not essential you do the second personal statement. There is some sort of additional questions you do have to answer though. I can't remember what it's called. It's like SAQ or something. Which you hand in that form and then forget about it. So yeah, I hope that answers your question.
What kind of questions
you.
are on that form?
Sorry, pardon, what was that?
What kind of questions are on that form?
Not a clue. I feel it's been so long. I only vaguely remember it being stuff like you had to set up a portal to view your application or passwords and generic stuff. I don't remember it being anything technical or anything you needed to worry about other than you did it before the deadline.
Okay, cool.
Yeah.
Sorry.
Any other questions about application process, ESAT, anything we've covered today?
Wait, yeah, sorry. So that like the Cambridge portal and stuff, do you need to then be applying before? So like the deadline's on the 15th, you have to do it before that to get that set up before that deadline?
I would have to check. I really don't remember that part. I assumed if you've done any applications and stuff like that, they would email you any sort of details if it is, setting up personal data or stuff like date of birth, all of that kind of stuff.
Okay.
I would double check I can double check the Cambridge website during lunch, or you can do it yourself. But I don't remember in honesty when exactly the due date is, if it's before or after personal statements in ESAT.
Okay, cool. Thank you.
Awesome. Right. I will take another stab at this Baker question for the next, 5 minutes. Try to make sure I go right. I remember seeing in the chat someone said that they had the mark scheme for it. So if they are Isaac, you said it's D in the mark scheme too. If you have a mark scheme, or the link to it, or you can put a screenshot of it in the chat, that'd be appreciated. Oh, beautiful. Oh, it was an NSAA question. Okay. 2017. Okay, yeah, cool. So yeah, thank you, Isaac. But yeah, I will. I'll run through this, try and do another explanation, see if it's D or E. That seems to be the main contention of answers. Well, you said it's D, but I'll try and find out why it's D. And then after that, I'm happy to go through if anyone's got any specific ESAT or NSAA questions which they don't understand why the answer is that. I'm happy to take a look at that. And then we'll pause for. We'll probably pause for lunch a bit after that. Yeah. So I'll see you guys in a bit. Oh, well, yeah, just go find questions that you want to ask me if you want, or take a 5-minute break. Oh, by the way, don't leave the room, because it'll be a pain to get everyone back into the right breakout rooms and readmit everyone. If you're having a break, even just for lunch or something like that, just camera off, mute yourself, and then just return to the call once you're ready.
Sorry, I arrived at 11 and therefore I missed like the starting bit. Is there any way I could get the questions that were done?
Sorry, I didn't quite hear the start of that. Can you just repeat that?
Yeah, sure. So I arrived at 11, so I missed the first, because you said you started 15 minutes early, so I missed the first 15 minutes. Is there any way I could get access to some of the earlier questions and maybe
Yes, you can, exactly, because I forgot to press record at the start. So what I
Okay.
was going to do is during the lunch break or in a bit shortly, maybe at like 10 past 12, I was actually going to very briefly run through the presentation from start to probably around halfway through the questions, probably around up to I think about here I started recording.
Cool.
So you can have the presentation personalized for you from the start if you want in probably about 15-20 minutes, if that's okay.
Yeah, no, that's great. Thanks.
Beautiful. Yeah.
Again, I'm just really sorry, but I missed your solution for question 14. Do you mind going through
This
that?
one here. Oh, I haven't done that yet. I'm about to start working on that. I've just been asking, people have just been asking general questions regarding the interview and process and stuff. So I will do my solution to 14 now, and then I will explain it. But yes, Mark scheme is D apparently.
Great,
So, yeah.
thank you.
Yeah, in the meantime, I've said just go if you've got any ESAT or sorry, ENGA or NSA questions you want to ask me, like specific ones, which I will try and solve on the spot. Go find those questions now whilst I'm solving this, and then we'll go through those questions in a bit.
Hi, sorry, I was just wondering, do you know how it works on the day? Like, because I know we have to go to like a test center and do it, but I was just thinking, do you get like a set amount of paper or like do you write on a notebook you bring yourself? Like, how does it work with where you put your work?
I'm afraid I don't know that. My best advice is take a notebook yourself in case. But I imagine what will happen is they will hand out paper, and if you need more paper, you can just ask for it. I doubt I can't imagine they'll give you like you're only allowed 3 sheets kind of thing. So take your own notepad and stuff just in case. But I
Okay.
imagine they will give you paper at the exam center.
Okay, thank you.
Hello. If I'm assuming people are happy, but I'll go over this into question 14 very quickly, the baker's one. The yeah, initially when I did it, I got E as well. And that's because the question is ambiguous. Basically, it depends how you define the 70%. If you think, I initially said that 70% of the revenue was profit and 30% was cost. And when you do that, you do end up with E. However, if the answer is indeed D, then what it means it wants to say is the profit is 70% of the cost. So if you that means you have C cost plus 0.7 cost, or C plus 0.7 C is equal to your revenue of 6.8, which means that you get a cost per large cake is cost per large cake is £4. You then have six of these smaller cakes. Each cake is half by half by half, so an eighth of the volume. And as we know, cost is proportional to volume. So you're only going to have an eighth of the cost per cake, but then six of them. So that means 6 over 8 times by 4, or 3 over 4 times by 4. It gets you a cost of producing these 6 smaller ones is £3. If your cost is £3 and you send £6.50, your profit on the pack of smaller cakes is £3.50, which is D. Is there anyone who still has any questions about that?
I was just wondering, for the 70% profit, is it referring to like as a percentage of the cost or the selling price?
So that's where the ambiguity is. If you got it wrong because of that, it's just unlucky. But what this question means, if the given answer is D, it means that you require the profit is 70% of the cost. So that means your total revenue, which is obviously going to be equal to cost plus profit, that's C plus 0.7 C. So you get your £6.80 is equal to 1.7 times the cost.
Yeah, thank you.
Everyone is happy with that? You said it was. Yeah, beautiful. So should we go through some questions and stuff like that? I just posted one. Yeah. Arj, I take it you want this question looked at.
Oh, it's fine. I've worked out the answer now.
Sorry, you're very quiet. Sorry, can you try saying that again?
Oh yeah. I worked out the answer. I was making you believe that.
Oh, beautiful. Okay. I'll close that one. Well done. Emil, question 20 and 31. What year is this? Ooh, fun one I haven't done. Okay. Right, so dive at the bottom of a lake of D fills a syringe. Okay, 720. Yeah. 9 times 8, 1/8 of the pressure. Okay, so you've got this 90, and as you go up, it's expanded by 8 times. From your ideal gas equation, PV equals nRT. Your nRT is going to remain constant because you've got the same amount of gas in it and you've got the same temperature, and obviously your constant is constant. So that means your pressure at one is equal to pressure times volume, and one is equal to pressure times volume at the other, and then it's also going to be equal here. Here you're going to have if you've got atmospheric pressure on top, and we're just going to call that PA, and he goes to the depth of D, and now he's clearly got what was it, 8 times the pressure, so 8 PA. That means he's got he's increased by 7 PA as he goes down. If you remember, was it rho GH is your pressure at any depth in a liquid, so it's linear. So at the halfway point, he's going to have an extra 3.5, or well, it's 8 minus 1 over 2. So an extra 3.5 times the pressure compared to the surface. So that means he's got 4.5 times the pressure halfway down than he does at the surface, which means he's going to have 1 over 4.5 times the volume compared to the surface. So I would have said that's if he's got 1 over 4.5 times 720. What would that be? If you divide by 9 and times by 2. Yeah, 4.5 is 9, 2 over 9. Sorry, my brain's gone blank. 720 over 9 is 8. 80 times by 2, 160. So I would have said A. That was, where's the you're 2023. Let me just get the ESAT papers up. That was 2023. These share bars and stuff do annoy me. 2023 question 20 was A. That's what I said, isn't it? Yeah. Are you happy with that explanation?
Yeah, thank you.
Very good. And then you also wanted 31 from this, didn't you? Let's just move this over here. Sorry, just moving this down because it's annoying. Ooh, these are no fun. Oh, wait, okay. Okay, so you've then got, if you integrate that, you're going to have 1 over 3x cubed over 3 minus root 5. And then you got to substitute in 3 minus root 5 and then minus 3 minus root 5. Yeah. If you substitute the first one in, if you take out the factor of 3 and you substitute the first one in, you're going to get 3 minus root 5 cubed over 3 minus root 5. So that gives you 3 minus root 5 squared. And then you're going to subtract, and you're going to get minus 3 minus root 5 cubed over 3 minus root 5, which is then going to be negative again, but then also 3 minus root 5 squared. So then you're going to do your final sum will be 1/3 of 3 minus root 5 squared plus 3 minus root 5 squared, which, yeah, I'm pretty certain that's right. Which is then 9 minus 6 root 5 plus 5. times by 2 over 3. Yeah, so then I've said, what's that? 14. What do they want it in? They want it fully expanded. Oh, they've given. I would have said 14 minus 6 root 5 times by 2 over 3. Have I missed a factor here? No, I'm yeah, I'm right. 28 minus 12 root 5 over 3, so 31e. Hopefully, honestly, this thing's behind me. 31e, yeah. Is that okay as well?
Wait, what was your integral?
So when you integrate this is a constant, so this isn't going to affect it, and you're going to get a third x cubed on top. Yeah.
Yeah.
When you substitute in for the first bit, you're going to get 3 minus root 5. If you take out the third, first off,
yeah.
So then a third minus root 5 cubed over 3 minus root 5 is the same as 3 minus root 5 squared. Yeah.
Yeah.
For your set negative, it's then going to be minus 3 minus root 5 cubed over 3 minus root 5, which then just becomes negative of 3 minus root 5 squared as well.
Oh, yeah, okay. That makes sense.
But then remember, it's because this is the second one, it's this one minus this one. So what you end up with is then 2 times 3 minus root 5 squared. Yeah, over 3.
Okay, yeah. Yeah, I think I times by 3 in the denominator by accident, I think.
Oh, fair. Yeah.
Yeah.
But,
isn't that question easier if you just take it to be symmetric? So you just do it for the top integral and you multiply by 2.
Yeah, that's essentially what happens. Yes, you are correct. You can it's if you notice it's symmetric and that works for you, great. I think it adds a whole extra 0.5 seconds if you don't. So it shouldn't 0.5 seconds shouldn't matter too much, but yeah, it is symmetric. So if that works, that works. Yeah, well done. Let's see what else was in the chat. End question. I was doing this anger question, wondering why the non-X. Oh, either okay. I'll solve that. Vishal, you put in the chat. It was what was your? You said, please, can you help with this one? And then I don't see a follow up, Vishal. Vishal is gone. Okay.
No, sorry. Hello, can you hear me? Sorry.
Hello. Yeah, there we go.
I thought I screenshot it and put it into the chat. Wait one sec, let me go. Right after. I'll copy it and paste it in the chat again.
Yeah, okay, yeah. That's great. Thank you.
If you look at the bottom, it should be there now.
Yep, just loaded.
Okay.
It was. What was that? H. Okay, so it's going to be very similar to the last one where you've got the rho GH, yeah? So your pressure at depth is going to be rho GH, but you also have an atmospheric pressure. So if you have PA at the atmosphere, and then you have some depth H, it's good. Your total pressure there is therefore going to be PA plus rho GH, yeah? You've got the volume ratio, and again, assuming constant temperature and your ideal gas equation, you then get pressure times volume is equal to a constant. Then pressure times volume is equal to a constant. So that means your P1 V1 is equal to P2 V2. P1 V1. Well, then if you find V2, so you want to find P2 then, because you've got P1 is 2 times 10 to the minus 3 over times by volume. I've said these in the wrong order. P1 is 1 times 10 to the 5. V1 is 2 times 10 to the minus 3. Divide by the volume 2, which is 4 times 10 to the minus 4. Then you get what? 0.5 times by 10. Yes, then you get 5 times. So then you get P2 is equal to 5 times 10 to the 5. Which is then equal to pressure atmosphere, which we've already been told. Have we been told it? Atmospheric pressure is 1 times 10 to the 5. So that means 1 times 10 to the 5 plus rho GH is equal to 5 times 10 to the 5. Rho is 1,000, so then rho GH is equal to 4 times 10 to the 5. Rho is 1,000, G is 10. So 4 times 10 to the 5 divided by 10,000, would be 50. Sorry, 40. So I've got, I don't know which year this is, but is 6A the answer?
Yeah, I think that's the answer. So I didn't know that for rho GH it's the change in pressure. Is it? I thought it was like the total pressure, so I got 50 instead.
Yeah, no, so it's the pressure due to the fluid. But obviously if the surface of the water has the atmosphere on top of it, you also have atmospheric pressure as well. So your total pressure will be the atmospheric pressure, or whatever pressure is pressing on the liquid, plus rho GH.
Okay, all right, thank you.
No. Sorry, let me go up. Sorry, there's a lot of stuff going on in the chat. So if anyone has any more questions, can you chuck them in at the bottom of the chat now? For the sorry, I might say it wrong, but Kirish, I would say the advanced maths and physics will be similar to maths 2 and probably like some of the physics questions on the ENGA. The physics section of the ESAT is probably a mix of normal and advanced physics. And then maths 2 is probably equivalent to like the advanced maths side. Okay, good. Circuits I can do. I did electronic engineering as my specialty. And for all 5 circuits have the same resistance. The non-volt means battery. Okay, so volt. Yeah, so voltage here is going to be 1 volt. Yeah, which means that's going to have a certain current, which is going to be V over R in this case, which is 1 over R. This resistor over here is going to have the same it's going to have the same current through it. So same current times same resistance is going to give you the same voltage. This one also has 2 volts over it. This point here has to have the same drop in energy, regardless of if the current goes through this side or if it goes through this side. So if this is dropping 2 volts, this is also going to drop 2 volts. However, if this is dropping 2 volts for the same resistance, it's got double the current going through here because it's only got half the resistance but the same voltage, so double the current. Sorry. Yes. Yeah, this should have double the current going through it. So 2 volts here, 2 volts there. 3 times, total of 3 times this current. Is going to go through here and here. So then you've got 2 volts plus 3 times volts here plus 3 times volt here is going to be 3 plus 2 plus 3 is going to be 8 volts. So I'd have said 16 was E. Yeah, is that the right answer for this year's question, Josh?
Yeah, that's right.
Yeah. Does that make sense?
Yeah.
Okay, sweet. Let me Kirish, I'll go through your one next. Oh, perfect. I've done this one before. Okay, very nice. This one I will draw it out. It's probably the easiest solution. Let's just shrink this down. Escape. And then can you guys see my OneNote up here? Let's just bring this back up. So you've got 10, 20, 90 degrees. Shaded area. Okay. So apologize for my drawing skills. They are atrocious. There's a reason you've seen me so far until now. Okay. So Zoom's just breaking a bit. There's a reason you've seen me for now. Mostly just explain stuff. But let's draw this here. Okay, there. That's atrocious. Sorry, also Zoom is blocking half of the stuff I see. Okay, that'll do. Right. So this is 10, this is 10, this is 20. These are tangents, it said, I believe. Let's close this, let's close this. Yeah, these are tangents. Yeah, so that's 90 degrees. That means this is a right angle triangle here. So you've got your hypotenuse and you've got this. If you look at this angle here, then, which we call it theta, sine of theta is equal to over A, in this case, 10 over 20. Theta is equal to 30 degrees. You will need this, which then this angle, alpha, 180 minus 90 minus 30 is going to be 60. Yeah, which means 2 alpha here is also going to be 60. Let's label that in there. I'll label this one here. You want the area of this total thing first before subtracting this bit of the circle. So this is going to be 20 squared minus 10 squared, and then root it. Just get length x, which is then equal to what? Root 400 minus 100, root 300, which is equal to 10 root 3 for x. Your area of this triangle is then just going to be a half times base times height. So in this case, a half, well, and there's 2 of them. So I'm just going to multiply by 2 at the start. So 2 times a half times 10 times height, which is 10 root 3, which is equal to 100 root 3. Yeah, which total area. This bit over here, area of a circle. So you've got 2 alpha, which is what, 120 degrees. So, and then we'll just go out of the area of a circle times pi r squared, which is equal to 1/3 times r is 10. So r squared is 100, so 100 pi. Your total area then should be 100 root 3 minus 100 pi over 3. I can't remember what the exact options were. 100 different things. They wanted 100 over 3, so that's, what is it? 100 over 3, and then 3 root 3 minus pi. I think that was one of the options. Yeah, so A, I'm pretty sure. I can't remember if that's the right answer, but I get A for that. I'm hoping that's correct. Sorry, can the person who shared this, I've forgotten who it was, confirm or deny the accuracy?
Yeah, 35 is A. You got it right.
Okay, perfect. Thank you. I have someone's coming up with Fleming's left-hand roll. Ooh, no idea where that's come from, but oh well. Let me join this one. So did this one get answered, or has this one has this one been answered in the chat?
I think it was answered in the chat. I think it was answered in the chat.
Okay, perfect. Thank you. I think that's it for now then. Great. That does take us to about 12:30, which I believe is now lunchtime. I will quickly run through the start of this presentation now, just so it's on recording. And anyone who missed the start of it, if you came in a bit late, you're welcome to stay for that. If not, you can just turn your volume down and ignore me whilst you have your lunch. Stay on call, just turn your cameras off and mute yourself, just because it saves us having to get everyone back into the correct room and stuff once lunch restarts. But does anyone have any questions they want to ask just before we break for lunch?
Hi, yeah, sorry, I didn't understand the answer in the chat. Like, I know they gave the answer, but I didn't understand it.
The Fleming's left-hand rule one?
Yeah, that one, yeah.
Where is that question?
I think it's in the chat.
Everyone's talking about which uni they're going to.
I think it's like recent. I saw it.
No, that's not it. What, recent?
Yeah, it was like it's showing up like really recently in chat for me.
Yeah. Oh, it was this one then. Yeah. Okay.
Yeah.
Sweet. Let's cleanse these. Oh, it's tiny, this question. 2 pixels. Switch that to English. So filled into the page. I cannot remember what is it? Force field current, I think. Force into the page. Okay. So force into page that. So if your force is into the page, left-hand rule, and then current, which passes down the rod, so from here to here, which I believe is your middle finger. Sorry, it's been a long time since I've done all this left-hand rule and stuff, so I might have the wrong fingers, the wrong directions, but that would mean your force is acting to the right. And then F equals BIL. So your force is equal to B is 0.5, I is 2.4, and then L is I would have said it's only 12, just because it's only 12 because that's the only bit that current's moving through. So 0.5 times 2.4 times 12 is what? 1.2 times 12, 1.44. Or sorry, 0.12 times 1.2 is 0. 144 or yeah, and then that's equal to, has a weight of, that's then equal to mass times acceleration. If you take g as 10, so that means it's got a weight of 0.04 kilos. I'm just going to focus on the calculator because I haven't written anything down, but I probably should have. If you wrote stuff down, that's sure the math wouldn't be too bad, but 2.4 times 0.5 times 0.12 is equal to your force. Divide by your 0.04 for your mass. And I've got an acceleration of 3.6 meters per second squared. So I've said 3.6 meters per second squared to the right. I think you should get answer B. Was that correct, chat?
Wait, could you explain why is it to the right?
Yes, well, sorry, was B the correct answer? I've been trying to get back to the chat.
I think it was F.
Was it F? Sorry, yes, I mean F. I said 3.6. My calculator says 3.6. Sorry, I do mean F. Yeah, no, I forgot I said it wrong, but I did calculate F. Right. So if you're happy with the calculation, F equals BIL, which is equal to mg, and you get your m as a tenth of this, that's fine. The direction, if you use your left-hand rule, your current is going to be going from positive to negative. So it's going to go up here, around here, and down here. So down, so it's going to go from here down here. So current's acting down the page. It says your B field, which is your pointy finger, is acting into the page, and that means your thumb, which should be pointing out, is pointing to the right. Does that make sense?
Yeah, that makes sense. Thank you.
Very good. Okay. Right. Let me see. Was there anything else on the chat? Yes. So, Ardit, Adrit, and Kirish, you are correct. So you use 12 rather than 20 because the current is only flowing through the 12 centimeter section, so it only experiences a force on that bit. The 4 centimeters at either end have no charge carried in them, so they don't experience a magnetic force. Yeah, okay, right. That seems to be everyone's questions for now. I'm happy to do this again later towards the end of the session if we carry on getting through stuff quite fast. So if you come up with any other questions later, you're welcome to ask me. Yeah. Yeah, any, right, 2 more minutes for any final questions before lunch, if anyone wants to ask them. Very good. Right, go enjoy your lunch. Please put yourself on mute and video off if you have, and then just turn me down if you don't want to watch me redo the start of the presentation. If you do want to watch me redo the start of the presentation, obviously you're welcome to stay. So, yeah. Right. Hello, everyone that didn't see this before. I am Ben. I graduated from Cambridge Engineering earlier this year. I specialized into electronic engineering. I'm assuming if you're applying to, so for Cambridge, I know not all of you are applying there, but the engineering coursework, you do 2 years of general and then 2 years of specialized. So you do a bit of everything at the start, and then, yeah, I did electronic engineering for my last 2 years mainly, little bits of other stuff, but mostly electronic. And I did gymnastics throughout childhood. I quit because of injury, but then I restarted and joined the uni team, and now I just do it recreationally for fun every now and then. And that's me. So just going through the ESAT specification and everything like that. It's an online test. There are 3 sections. You have to do maths 1, and then you get a choice of 2 of the following. If you're doing natural sciences, it can be any 2 of those 4. However, if you're doing engineering, you have to do maths 2 and physics. Each section is 27 multiple choice questions, 40 minutes for each section, so you get about 1.5 minutes per question, which is very tight. Timing will be your biggest enemy. You get 1 mark for correct answer, none for incorrect answer, which means that you should guess. If you're unsure of anything, just guess it. You can flag questions for review and return to them later, my main advice for that is even before you leave it, just take a random guess, because for if any chance you don't manage to have any reason you don't have time to return to it later, you might as well have an answer in there anyway. So take your best educated guess that you can, or if you don't have time, just a random guess. But never move on leaving a question blank is my best advice for that. Yeah, so the former for the natural science admissions assessment was the NSAA. That had various sections and stuff like that. So it had section 1, which was maths, and then you had to choose one of physics, chemistry, or biology, and then another of advanced physics, chemistry, biology. This had a total test out of 2 hours. The ENGA, which was the old engineering one, had maths and physics in part 1 and then advanced maths and physics in part 2. Again, it was 2 sections of 1 hour each. When looking at especially the ENGA, the main applicable questions are going to be those from section 1 of the ENGA. For the NSAA and the ENGA, it was also about 1.5 minutes per question. So using them as practice papers for the ESAT is quite good because they'll be about the same difficulty and time pressure. Yeah, the ESAT now is for both engineering and natural sciences, in case you didn't know. But make sure you're doing the right sections for your chosen discipline. I've given you most of the general advice. Ask anything throughout. Maths 1, 40-minute section. Everyone has to do it. It should all be about year 12 content. Every now and then you might see stuff in the NSA or ENGA papers which isn't within the specification now. If that is the case, which is quite rare, don't focus too much on it, because apparently there's been some stuff to do with binomials and that which are no longer in the ESAT. But yeah, make sure you know your year 12 maths and stuff particularly in depth. And yeah, the questions focus on being weird rather than difficult, and they also try to make sure that they are possible to do quickly if you notice the right trick. That said, time pressure will still be your biggest issue. Make sure you know all of these. Make sure you know your BOD mass or BID mass, however you know it, prime factor decomposition, direct and indirect proportions come up quite a lot, so it's worth knowing. Quadratic equations will be very essential. Interior and exterior angle polygons, I recognize a lot of you haven't done this since about year 7, but do make sure you just remember the formula. So the exterior angle is 360 over n, and the interior sum of angles is n minus 2 times by 180. Yeah, Pythagoras theorem, trigonometry, circle theorems. You will need volume and surface area of pyramids. And then there's some stats and probability as well. Make sure you're confident with all of these. If you do have a particularly weak area, I would say, like, let's say you're awful at statistics, but you're very strong at the rest of them, skip the statistic ones and leave it till last, because you might as well make sure you spend you get through all of your strong ones, and then if you need to, you can just guess these at the end when you're hurried for time anyway. Key formulas that you must know: area of 2D shapes, surface area and volume of 3D shapes. The ones that are slightly rarer and you may have forgotten are those of a cylinder, of a cone. So surface area of a cone is the base of it plus this slanted height, and then the volume as well, which is just a third times the height. Make sure you know your quadratic formula. It doesn't pop up too much. Most of the questions I've seen that use a quadratic, you can factorize. So make sure you're very good at your factorization, but you will also need to know your quadratic formula, and just make sure you know if the discriminant is less than 0, equals 0, or this should be greater than 0. But make sure you know if it's going to have no solutions, 1 solution, or again, this should be greater than 0 for 2 solutions. And then finally, one thing that also does pop up a lot is difference of 2 squares. So make sure you can easily see that, spot it, and immediately factorize it, because this will pop up quite a lot. Completing the square is very useful. Yeah, make sure you can do it. Make sure you understand where it comes from. Yeah, it's also the origin of the quadratic formula, obviously. So if you know one, you probably know the other, but completing the square is probably more useful to know than the quadratic formula for the ESAT. These questions we did already. I will run through these quickly just because of time, but originally in the first time running through, I got the other students to answer this. Just a question, can I ask, is anyone actually watching this?
Yeah, I am.
Beautiful. Okay, Emil. Right, I think it's just me and you. So, Emil, do you want to try these by yourself, or do you want me to run through the answers quickly?
Could you like run through the answers?
Beautiful. So, in the inversely proportional, so D is equal to K over R. Yeah. Initially, you know this, so you know that K is going to be, so then you have 125 is equal to K over 16. So that means that you know 16 times 125 is equal to K. Now, just because I can see we're going to have to use 40 days, and I know 16 and 40 have some nice common factors, you know, 4 or 8, I'm actually just going to leave K is equal to 125 times 16. I'm not going to bother solving that because it then means how many days are needed to complete it. And you should, once you substitute it in, 40 is equal to 125 times 16 over R. R is then equal to 125 times 16 divided by 40. Factor out the 8 from each of these, you get 125 times 2 over 5, which then becomes quite easy to solve. That's 250 over 5, which is 50. So you need 50 people to complete the research in 40 days. Yeah?
Yeah.
Beautiful. This one quite easy, just scaling factor problem. AB has length of 4 centimeters. A similar one but bigger has 9 centimeter AB. So that means to get from the smaller volume to the bigger volume, it has to be 9 over 4 cubed times 30, which is 4. I get 342 to the nearest integer. Yeah. This one over here. Sorry, I'm assuming you're happy with that, Emil?
Yeah.
Beautiful. This one over here. If you cut it into this small rectangle is similar to the oval large triangle before. So it's talking about A4 versus A3 and A5 paper. And you've got to show that this length is root 2 times the width. This question is not something that will pop up in the ESAT because obviously it's only multi-choice. There won't ever be a prove that question. Similarly, this one you needed a calculator for, and I don't think they'd ever, so they wouldn't give you this sort of question, the ESAT, but it's just a good warm-up. So if this has, if the ratio of this side to this side is the same as the ratio of this side to this side, then you get length 1 over width 1 is equal to length 1 over, sorry, length 2 over width 2. But you notice that your width 2 is equal to half your length 1. I wrote down the equation for that earlier. Where did I put it? I'll just do it again. So what L1 over W1 is equal to L2 over W2. And then L2 is equal to, so your length 2, which is this side here, is equal to W1. And then your width 2 is equal to your L1 divided by 2. So that means when you substitute that back in, you get L1 squared, so length 1 squared, this one, over width 1 squared is equal to 2, and therefore the ratio of the two sides, L1 over W1, is equal to root 2. Does that make sense?
Kind of, I think.
Let me run through it on OneNote. That's probably the easiest thing. So I should have just gone straight to OneNote rather than scribbling. Apologies. So you've got a rectangle, and this is going to be L1. This is going to be L1. This is going to be W1. This is also going to be length 2, and this is going to be W2. Yeah?
Yeah.
Perfect. So now you know that the ratio of these, if these are similar, has to be the same. So L1 over W1 is equal to L2 over W2. But you'll notice L2 is just W1. And then width 2 is L1 over 2. And you notice if you rearrange that, if you multiply both sides by L, divide both sides by W1, and then this is 1 over 2, so it just becomes 2. You get L1 squared over W1 squared is equal to 2. You happy with that?
Yeah.
Beautiful. And then L1 over W1 is equal to root 2. And that's your proof.
Okay. Thank you.
Yeah. This one, P is proportional to Q squared, and Q is inversely proportional to R. And then it gives some values. So if you have 2 is equal to K times Q squared. Let's just run this through very quickly. So you have what? 2 is equal to K times 4 squared. So P is proportional to Q squared. You get your K is equal to 1 over 8. Yeah?
Yeah.
And then Q is inversely proportional to R. So when 2 is 5 R, so 2 and 5, so then you get 2 is equal to, I'm going to call it K2 over 5. K2 is equal to 10. Yeah. And you've got P equals K1 Q squared, which is, and then Q you can substitute in, you've got K1, and then you've got K2 over R squared. Yeah, so this is your substitution of Q back in to P, which is then equal to K1 K2 squared over R squared. And then your factor here, K1 K2 squared is equal to 10 squared divided by 8, which is equal to 100 over 8 is what? Divide both by 425 over 2. So you get P 25 over 2 R squared. Yeah?
Yeah. That makes sense.
This one, did you see me go through this one? Because I went through this one later.
Yeah, I did, yeah.
Very good. Let's just go back to the presentation. You will need to know your circle theorems. I haven't seen too many circle theorem questions pop up, but you will need to know them. So, angles potential is twice the angles potential from circumference. Are you happy with all of these?
Yes.
Very good. So, very quickly, A, B, C, D, where AC and BD are diameters and AB is parallel to DC. So this is parallel to this, and this are diameters. Prove OAD is congruent to BOC. So I did this very simply. This isn't very vigorous, but this is a radius, this is a radius, this is a radius, this is a radius, and these two angles are equal. So for me, side angle side means that they have to be congruent. Yeah.
Yeah.
If you do it slightly more vigorously, then you see that this angle has to be equal to this angle, and this angle has to be equal to this angle due to this parallel theorem when you get the Z shape. But then you're just proving that you've got the same, which angles correlate to which.
Hi, ask you something before you go to the next question.
Yeah, of course.
Callum, he's doing the other ESAT. He said he's going to do chemistry when you're. So is your next section maths 2 doing?
I do not know. Yes, I'm on maths 2 next.
Yeah, because I'm doing maths 1, maths 2, and chemistry, but then he's going to do chemistry now when you're doing maths 2, so it clashes. So he asked if he can do physics first, so I can join the chemistry late, like next, and then do your maths 2 last. But then
I'm happy to do that. Yeah, I'll double check once everyone comes back from lunch break, just because of make sure no one else has any similar clashes, which that would screw up, and then I'll basically take it to a popularity vote.
Okay, cool.
But at the moment, yes, I'm perfectly happy to do that.
Okay, thank you.
Right. This one very quickly. Points and circumference OAD. So AD is tangent to OA. OCD is a straight line. Calculate angle ABC. So we want to find this one up here. So you know this is 90 degrees. You know this is 38. That means this one has to be 52. Yeah, so can you see OAD, sorry, is 52? So, Emil?
Yeah.
And then this one, so this angle is going to be double of this because of that circle theorem, which is the weird pointy one. But so ABC is half of AOD, which gives you ABC is 26.
Okay. Yeah.
Oh, sorry, my voice is dying. This one over here, RST is a straight line. This angle 75. You want to find this angle that's shown here, QSO. And then it's worth noting that these two are the same length. So key thing, this angle here, 75, is going to be the same as this angle up here of SQP. So if this is 75 and these two are equal, that means this is half of the remaining angle. So 180 minus 75 is 105. Half of 105 is 52.5 for each of these. Because TSO is 90 degrees, since this is a tangent, that means this angle here of OSP must be 15 degrees. So 52.5 minus 15 gives you 37.5 as your final answer.
Yeah, makes sense.
Good. I disagreed with some of this. You are aiming for 100%, but you have to be realistic. You will probably not get it, mostly because of the time requirement. It is very tight on time. And when I did the ENGA in my year, I ended up guessing the last, out of 40, I guessed probably the last like 5 or 6 questions. Like not even like educated guess, just literally scribbled A, B, C, D kind of thing. So aim for 100%, but due to the tightness of time, you will probably not get it. And that's okay. Is basically what I'm trying to say. It's okay if you don't get 100% because almost nobody will get 100%. Anyone that does is just a human calculator and is a very rare example. Because a minute and a half per question, including reading time, is not a lot. So aim for 100%, but don't worry about it. Questions are not strictly by difficulty. So if you come across a difficult question, you can, I would say, guess an answer at the time, skip it, and then if you've got time, come back to it. You can flag for review if you want. But all questions are worth the same marks, the difficult ones and the easy ones. So there's no point if you're looking at a question for more than 30 seconds without any understanding of how to do it, just move on and go to the next one, flag it for review if you've got time at the end. These are 6 sections that you should probably know for Maths 1. Numbers, ratio, proportion, all that. Yeah, we've been through what specification you should use. Do you have any questions on any of that, Emil?
No, yeah, everything's good.
Sweet. Use the factors multiple choice. So this one, you can see it rearranges to 2x squared plus x minus 15 is greater than or equal to 0. And that means if you think of the shape of a quadratic, and I'll draw this out just for the recording. I don't know the intersects of this because I haven't bothered solving. But if this is roughly, let's say your graph looks roughly like this, yeah, because it's a 2x squared, it's a positive x squared, and you're looking for when it's greater than, it's going to be this region over here and this region over here, which means that your form is going to be, if I call this A and B, x is less than or equal to A, or x is greater than or equal to B. So that's got to be the form of the answer, and you'll see only two of these options satisfy it. So without even solving it and really just spending literally 1 second looking at it, you can already narrow down to two possibilities of answer. So if you're running tight on time, you can take an educated guess and just hope that it's going to be E or hope that it's going to be C. So multiple choice is very useful. Yeah, and then obviously if you want the exact answer, you need to solve for the intercepts, which wouldn't be too bad. I think you'd get a 2x minus 1, 2x minus 3, probably. Yeah, 2x minus 3, probably. So I think C would be your correct answer in this case. Minimize the number of calculations you need to do. This question is not a good example of it. I don't see any way to do it better, but it's saying n-side polygon has a 4 degrees larger exterior angle than a regular polygon of n plus 3 sides. I'll just run through how to solve this one quickly. So it's saying n over 360 minus 4, because it's 4 degrees larger. Sorry, I've written this the wrong way around. It should be 360 over n. Do stop me if I'm saying anything silly. 360 over n minus 4 is equal to 360 over n minus 3, because this one is 4 degrees larger. If you multiply by n and rearrange, let's just multiply by n, so you get 360 minus 4n, so 360 over n minus 3 over n. If you then multiply this out, so then you get 360n minus 1080 minus minus 4n squared, and then plus 12n, and that's going to be equal to 360n. You'll notice, sorry, 360n. You'll notice this cancels. If we rearrange to make the n squared positive, you get 4n squared minus 12n plus 1080. I think I've gone wrong somewhere here. We'll find out in a bit. Just divide through by 4. N squared minus 3n plus 270 equal to 0. You'll notice the factors for that are 15 times 18 make 270. I've definitely got a negative wrong somewhere. That's correct. Because you would say this is, oh no, I think I'm okay. N, and then this will be, you want minus 18 and plus 15. I think I've got a negative wrong here. Give me 1 moment. I've run through this a bit too fast. 360 over n minus 4. That makes sense. That makes sense. (360n) minus 180 minus 4n squared plus 12n is equal to that. 4n squared.
Wait, was it not n plus 3?
Pardon?
Was it not n plus 3?
It was n plus 3. You're correct. Thank you very much. Sorry, yep, that was silly of me. So that changes, then you get 360 n plus 180, sorry, 1080, minus 4n squared minus 12n. Yes, that's looking a lot more normal. Again, the 360 cancel out, then you get 4n squared plus 12n minus 180. Yes. Then you get n squared plus 3n minus 270. And you should get you'll have plus 18 and minus 15. And from here, obviously, the only real answer you can use is positive. So n equals minus 18 is not valid. So then n is equal to 15 is your final correct answer. Sorry, thank you for that catch on my mistake. Then, sorry, let's go from here. Mental skills, mental maths, graph. Yeah, mental maths needs to be good. You need to be on it, especially with the arithmetic and algebra. And then you need to be good at graph sketching and just a couple other things. Sense check, I slightly disagree with in terms of you do need to check when you're uncertain. But if there's a question you're 100% confident on, like you're very confident every step, the first time you do it, you don't have a lot of time to check stuff. So I wouldn't say check the questions you're confident on. Only check the ones where you're a little bit iffy about your working or something like that, or you think you've got an unrealistic answer. So do sanity checks and stuff, but don't do in-depth checking back over your working unless you really need to. Graph sketching skills. The easiest way to show you this was on Desmos. So you've got sine. So if you have your sine of x to start off with, you know it looks like this. This should be a graph that you can memorize. It starts from 0, goes up to 1. If you then shift it pi, what you're going to do is, so if you do sine of x plus pi, you're going to shift it pi to the left. So then you can see now, so originally this was your start point, it's been shifted pi, sorry, this was your start point, it's been shifted pi to the left. So now it starts going negative. Yeah, but it still maintains the same shape. But for this graph, you want to do double the frequency. So it means it, because it's the 2x, so it's now completing a full cycle within pi. Yeah?
Yeah.
Well, one of the other ones was, if you had, was it x minus 1 cubed plus 4x? So for this graph, if you think of just let's start off with x cubed, and then you've got this minus 1. When you transform a graph by adding minusing 1 to the x, you shift it 1 to the right. So you can see that your new neutral point has now been shifted to 1 over here. If you then add on top of that 4x, oh yeah, that worked. 4x over here, you're just going to add these values to this value. So here you can see it adds nothing, but up here you're going to add a 2 to this 0. So now you should see that this goes through the point of 1, 4. Sorry, I don't know why I said 2. It's going to add 4 to your thing, but it should go through. But when you do plus 4x, yeah, you can see that it does indeed go through your 1, 4 point. But yeah, so you have quick graph sketching skills. Make sure you know where to how adding works, how multiplying works, and everything like that. Is that graph okay?
Yeah, thank you.
And then final graph was it x plus 2? Why is it good? Let's just clear this. X plus 2 over x minus 3. Right. So for this graph, key points, if you notice down here, your asymptote is going to be x equals 3 is going to give an indefinite answer. So that's going to be your asymptote. And you can see that over here, where it arcs off over up to positive infinity and negative infinity. The key other thing is where it equals 0. It's always good to know where your intercepts are. So when y equals 0, you can see x is going to equal -2, which is down here. And then finally, notice the reciprocal nature. I know it's a linear on top of a reciprocal equation, but your reciprocal is going to dominate in this case. So you've got this overall reciprocal graph. And then other key thing is where it goes to as x tends to plus minus infinity. If you take x equals infinity here, the +2 and the -3 are going to make no difference. Like infinity +2 and infinity -3 is just infinity over infinity. Infinity over infinity is 1. So you'll see that as this trails off to infinity, you're going to get y tends towards 1. You can see it just gets a little bit smaller as you drag it out. Is that all okay?
Yes.
Beautiful. Where in the PowerPoint did you join? Because I think that you didn't do. I think this is where I started recording. Were you here? Did you do this?
Yeah, I was here for that one. Yeah.
You were here for this. Okay, very good. Wait, sorry, you did say here for this, didn't you?
Yeah.
Beautiful. Okay, I'll stop there because I'm pretty sure I started recording here as well. So, go take a lunch break. We've got about 25 minutes. I'll restart at 1:30. I'll go through physics as we discussed. Yeah, just mute your camera and mute yourself and turn your camera off. And I'll see you in 25 minutes.
All right, thank you.
Hello guys. Sorry, I've only just had a chance to actually cook and stuff like that, so I'm just going to take 3 minutes to eat if that's okay. But we'll restart very soon. Right, guys, is everyone ready to start again? Even just a wave in chat or something like that, just to make sure people have returned. Sweet. Yeah, so we're gonna do physics now, just because a couple people who are doing maths, both maths 2 and chemistry, like they need to switch between presentations. So Callum, I think it's Callum, who's doing the other side of ESAT at the moment, is currently going over chemistry, I believe. So we'll go over physics now, and then we'll do maths 2 later, so that he can do that. Is that okay with with everyone, or is it that going to or is doing physics and biology at the same time going to, sorry, physics and chemistry at the same time going to screw anyone up? Okay, sweet.
So excuse me, we need to do chemistry. We were planning to do chemistry in the next bulk season. So we would need to do maths too now.
Well, I was told that chemistry was happening now over in the other chemistry was happening now in the other session because there's 2 ESAT sessions. And then we'll do so if we do physics now whilst they do chemistry, it gives people doing chemistry to then come back and do maths too after.
Chemistry.
Pardon?
How do we switch to chemistry?
It should be in another breakout room. So if you, I imagine you'd have to exit this breakout room, then go to the other appropriate one.
Okay. Yeah. Thank you.
If it's not, if they're doing biology at the moment, let me know. Because then I'll switch to doing maths 2 now, and then we'll do physics after whilst you're doing chemistry in the other one. But if you don't return, I assume they are doing chemistry now.
Okay, we switch now.
Yeah. That good with everyone? Right. I assumed if you're staged, you're happy to go through physics now and then maths 2 later. As I said, if there's any issue, we will. I'll switch to doing the other one. To the maths 2 now if they're currently doing biology. But physics. It's the same idea. It's another 27 questions, 40 minutes. There will be a mix of, I imagine, basic and advanced, considering I know the old ENGA had advanced maths and physics as part 2, but now it'll just be a mix. So yeah, I think this is mostly just physics questions it's going through. So can you guys take a shot at this one for me? Is everyone done? Is anyone happy to go through a solution? Right, time to pick on people. Let's go Sam Ginger. Are you willing to give a solution? Can you guys hear me okay? There's nothing popping up. Okay, right, I'll go through a solution then. So, speed of light in a vacuum, and you've been given a wavelength. The higher the wavelength, the lower the frequency, or the shorter the wavelength, the higher the frequency. Ultraviolet is higher than visible light in the frequency spectrum, which means it's got a shorter wavelength. So if you take the highest possible frequency of visible light, which is going to be 3 times 10 to the 8 over 400 times 10 to the minus 9, you then get 7.5 times 10 to the 14. And as I said, that's the upper bound of visible light, which means it's the lower bound of ultraviolet, which means the minimum frequency of ultraviolet will be 7.5 times 10 to the 14. Which, so I'm expecting G. Yeah. A potential difference across them, and then can
Oh,
you
wait,
guys all take a
sorry.
shot at this? Yeah.
Can we go back to the last one if that's okay?
Yeah.
I didn't
This
get
one?
that. Yeah.
Well, do you want me to re-explain it, or do you want a little bit longer to think about it?
I don't know what I did. Like, I ended up getting F. So I don't know what I did wrong. I'm a bit confused.
Yeah,
So you
same.
got 7.5 times 10 to the 14.
No, I got F. So I got 4.3 times 10 to 14. So I'm really confused.
Was it not 3 times 10 to the 8 over 4 times 10 to the minus 7?
It'll be times,
is
yeah,
0.75.
it'll be 4 times 10 to the minus 7 or 400 times 10 to the minus 9, whichever you're more comfortable with, yeah. So it'll
So
be
7.5
speed of
times.
light divided by this number.
So if visible light's like lowest wavelength is 400, isn't that the upper bound for infrared?
No, so
I'm just confused.
let me find an infrared spectrum. EM spectrum. This image will do. Can you see this image? Is this big enough?
Yeah.
Yeah. So longer wavelength corresponds to this one. So ultraviolet has a shorter wavelength than the visible light. So you're going to get
Right, yeah. I can
yeah.
see.
So the shortest wavelength of visible, the shortest wavelength of visible light will be the upper bound of wavelength for ultraviolet light. But then because wavelength is equal to speed of light over frequency, it means the highest frequency of visible light is the lowest frequency of ultraviolet. Yeah. So
Right.
even if you look here, the frequency is increasing as you become more towards the ultraviolet. So you got times 10 to the 15 here and times 10 to the 16 here.
Oh, and that's the minimum frequency. Okay, yeah, that makes
Yeah.
sense.
So if you do the what was it, the speed of light divided by the shortest wavelength, that will be the upper bound of frequency for visible light, which is the same as the lower bound of frequency for ultraviolet.
Oh yeah, that's fine. I forgot that I was increasing frequency. I thought it was increasing wavelength. That's my bad. Yeah.
Oh yeah, no worries. Just keep it in mind. Higher frequency. Have you done photoelectric effects and stuff yet?
Yeah.
Yeah, so you know energy is equal to HF.
Yeah.
Yeah, so that means the higher the frequency, the higher the energy. And obviously gamma radiation has the highest energy, which means it has the highest frequency.
Yeah, that makes sense.
Yeah. I don't know if that helps at all to remember
Yeah,
it,
it
but
does. Yeah. Thank you.
Sweet. Yeah, can people now take a shot at this one, please? People finished? Would anyone like any more time?
Yeah, can I just get another second if that's all right?
Yeah, sure. Right. Is anyone able to go through the solution now?
I could if you want.
Yes, please. Yeah, go ahead.
So the power is since P equals IV, the power is 500,000 watts since it's 1,250 times 400. If you times that by 0.45, that gets you 225,000 watts for the output power. Times that by 4, you should get 900,000 joules.
Very good. Yeah, that's exactly what I got. I'm really hoping that means we're both right. Answer
Oh,
is
wait,
C.
sorry, I just want to ask, do you have any tips for like questions like this? Because they've got like a bunch of zeros and it's really annoying to work around it. Especially
My main thing here is you've got this system efficiency of 45%.
yeah.
And in fairness, I didn't do it this way, but 450 times by nope, actually ignore me. I'm completely chatting out my ass there. No, I don't have a special trick for you, I'm afraid. If there's a bunch of zeros, sometimes writing it in standard form can help. If you know you just got 10 to the 6 over 10 to the 3 gives 10 to the 3.
Yeah.
Or just look along and do the zeros. I think the best tip here is practice.
Okay.
Because what numbers have you got here? You got 400 times, that'd be 5,000, 500,000, 2 million. None of these numbers are horrible in fairness. Because
Yeah.
like four times 1,250 is just 5,000 times the 100. It's going to be 500,000. This will get you
Yeah.
to 2 million. If you just times this by this by this, that gets you the input energy, which then
Yeah.
gets you to 2 million. And then 45% of 2 million shouldn't be
Yeah, that's
hopefully
fine.
that bad. So yeah, my only advice, if any, would be you don't need to do all the multiplication as you go along necessarily. Because
Yeah.
sometimes stuff cancels out towards the end. I don't remember if you saw in the first session
Yeah.
when I said, was it rather than doing 125 times 16 to later divide by 40, just keep it as 125 times 16 and don't bother cancelling out until the very end sometimes.
Yeah,
So
that makes
yeah,
sense.
don't think just because you can get a number, you have to get a number. You can just sometimes leave it as an equation.
Oh, okay.
That'd be the only bit of advice I've really got. Someone's got their hand raised. Just you can unmute yourself. Yeah.
Yeah, I was just gonna say that you can ignore the zeros because all of the answers are like different, like they've got a different value at the beginning, so you can just ignore the zeros and then you get 9 and then you know it's C.
Yeah, you can do that. I wouldn't advise that for every question because sometimes if like let's say they had a 90,000 or a 9 million here, then that approach doesn't work too well. So I wouldn't advise it as one for every case. But in this question, you're right. That's a good observation. And yeah, that would be viable for this sort of question. But pick and choose the questions you do that with.
Right.
But yeah, no, it's good. It's good advice for this question. Let's have a go at this one. Is everyone happy with their attempt at this? Would anyone like to share their answer?
Is it A?
It is indeed A. Yeah, I know. I flashed the solution up. I just checked my thing. Can you explain why it's A, please?
So the background count, you can see it's 20 from the graph because
Very good.
using it below it. So you have to subtract 20 from the 120, which is 100. Half of that's 50, but then you have to add the 20 again, so it's 70. Wherever a 70-meter graph is 40 minutes.
Yeah, very good. Well done. That's exactly right. Yeah, they say exactly what you said. Well done. Oh, I've done this question. This question, I think, wasn't nice. Oh, not quite. I've done a very similar one, though. Right. Can everyone take a shot at this one, please? Would anyone like longer on this, or are you all happy? Sweet. Would anyone be willing to go over their solution?
I can go over mine.
Yeah.
So I got E32.
Very good.
So it's traveling 16 centimeters, so 4 times 4 for one oscillation. So that's 0.16 meters. And then it's doing that 10 times a second, so 1.6 meters a second. And then times 20 is then 32 meters.
Yeah, very good. Well done. That's exactly right. I'm assuming everyone's happy with that. The only thing I've seen, so people might get caught out on, is as a transverse wave, the particle is actually just going up and down. It's the energy that moves along, but the particle itself is just going up and down. And as it's got an amplitude of 4, it means it goes down from peak to peak once and up peak to peak once. So two per wave, which is where sorry, you've got a Menzies. So I'm just gonna go Menzies. 4 times, because it's 2 times 2 times 4. 4 being the amplitude for it to travel. But yeah, well done. Oh, they're showing exactly on this diagram. So yeah, travels 4 centimeters each way. Yeah, next one. Is anyone still going, or or are you all happy? Okay. Would someone be willing to share their solution, please?
Yeah, I don't mind. So, because we know the current in the circuit's 8 milliamps, so if we read off the graph, the potential difference across the diode at 8 milliamps is 1.2, and which the potential difference across the resistor must be 6 minus 1.2, which is 4.8. And we know the current already, so it's just 4.8 divided by 8 times 10 to the minus 3, so it should be 600.
Well done. Yeah, good. I assume everyone else is happy with that. I can draw the circuit diagram if you need, but that was a very good explanation. Yeah, this is exactly what you described. 600. Ooh, this is interesting. Okay. Is everyone happy? Does everyone require any more time?
I don't need any more time, but I didn't get an answer for this one. So if we could go through it.
Yeah, that's fine. Is anyone else willing to share their answer?
Is it A by any chance?
It is. It is indeed. Yeah.
Oh yeah.
Is it easier if I show it with this? Is that or do you want to just talk to it?
Yeah, I think you should show it
Yeah.
because it's quite difficult to describe. But you want to basically split the integral. You want to split, I believe it is 4 to minus 2. Is that it? Okay, but yeah, you want to split 4 to minus 2 into 4 to 2 and then 2 to minus 2. Because what that lets you do is cancel out the 4 to 2. That makes sense. And then you're just pretty much left with, once you just realize that it's quite straightforward because then it's just simplifying it down. I don't think I can really like describe it without writing or anything, to be honest.
I don't know what they've done here, why they've included this term. Because you're right, you should split it minus 2 to 2 and 2 to 4 to get this. And then yeah, I don't understand where they've come in with this extra term. I think that might be a typo. But this is your first equation, so 2 times this bit plus this bit equals 4, which is just exactly what's written here. And then 5 times, and then this is your split here, exactly as you've done. Equal to 7. So you get 4 times that equals 7, and then it's just a simultaneous equation. This is 11 over 6 over here. And substitute it in. Is everyone happy with that? Would anyone like a bit more time or a bit another explanation?
It does make sense, but I was just like, can you do this with like every single integral? Like, how do we do that with the limits? Is there like
yes, you can do it with every integral. The only thing would be if there's issues with positives and negatives, like purely mathematically, yes. If you're doing like finding total area and stuff, because if it then goes below the graph, you get a negative integral. So if you're doing it in regards to area, that's where you got to be careful. But purely from a mathematical definition, yes, you can do this.
So have we split it up because the difference is the same? So 4 to 2 and minus 2 to 2. I just don't get what.
No, it's not that it's the same. It's just if you have some function. Oh, sorry, my pad's gone weird. If you've got some function like this, what do we have? We have minus 2. This is your f of x, let's say. And they've gone from minus 2 to 4 here. Yeah. And this is 4. Sorry, 2. They've defined this as 2. They could have done minus 2 to 0 and 0 to 4 or something. But the first integral, minus 2 to 2, just means this area. And the second integral, 2 to 4, just means this area. So then the minus 2 to 4 just means all of this area, which you can see is the combination. I don't know why that rubbed itself out.
Right, yeah, I can see that now. Yeah.
But you could have split this anyway. You could have done minus 2 to 0 and 0 to 4, because then it'd just be this plus this.
Right, yeah, that makes sense.
Yeah, so it's just through where the limits, and it's a good thing the limits overlap. If they said like if they'd gone, let's say 0 to 2 and then 1 to 4, and they'd said this area and this area, you don't know, you couldn't do it then because you don't know what happens here in the middle of here. Like this could be really wonky, it could have sign, it could be something pretty different. It doesn't matter, but because the limits match and you have covered the entire section of the integral, you can do this.
That makes sense. Yeah, thank you. Yeah.
Sweet. Yeah, let's go. Yeah. Would anyone like any more time, or are you guys happy? Okay, and do I have anyone who's willing to volunteer a solution? In fairness, this is one word graph.
Sure, I could.
Yeah. Go on. You explain it. I can draw a graph if you need to, if it helps visualize it. But
Yeah. So I noticed that if you put that as f of x, if you f of -1 is equal to 0.
Yeah. So was it minus 2x? Was it +4? Was the equation, I think? -4.
-4, yeah.
Yeah. Okay. Yeah, go on. So you've got.
So f of -1 is equal to 0, so you can take out a factor of x plus 1. And if you divide it, that leaves you with the polynomial x squared minus 3x minus 4. And then x squared minus 3x minus 4 is x plus 1 times x minus 4. So you get x plus 1 whole squared times x minus 4. So when y is equal to 0, x is -1 or x is 4. But since it's x plus 1 whole squared, you know that at -1 it's a stationary point. And since it's positive x cubed, you'll know that it is a local maximum point. So yeah, and then it goes down and then connects through 4. So x is greater than 4.
Yeah, good. Well done. Yeah.
How do you know that's a maximum at -1?
Sorry, pardon?
How do you know if it's a maximum at -1?
You just have to. Oh, knowing it's a maximum, the best way I would say is because it. You can think of it crossing the x-axis twice at the point x equals -1. So you can imagine it goes up then down again at the same point, which means it must kind of turn around.
Okay.
So yeah, it's just because it's a repeat, and you can imagine it's got to go through there twice, but obviously it only goes through there once, so it has to turn around at that point.
Okay.
Yeah.
How did you find the quadratic so quickly? Like, how did you divide the cubic by x plus 1 so quickly?
Do you want to take this one, or should I?
Me?
Yeah, it was your solution.
So I've done some questions, and often you just need to, if it's a cubic or something, you just need to sub in values. Often it's 1 or -1, so you just sub it in.
Yeah, but like when you divided the cubic by x plus 1, how did you get the quadratic so quickly? Like, did you do long division, or did you do like some other method?
I did comparing the coefficient.
Yeah, because if you look at here, if you've got ax squared plus bx plus c is kind of your general quadratic, yeah. If you've got if you know you want to get x cubed, the coefficient has to be 1. The only way you can multiply this to get a coefficient of 1 is this term here, x times this x squared term. Nothing else gets you an x cubed term. So that means a has to equal 1 right off the bat, because it's got to equal this. Similarly, for the constant term, the only constant that pops out of this is this 1 times c. So that means c has to equal -4.
Yeah.
And the only one left is b.
It's just that middle one's quite difficult, I think.
Yeah, but then just choose like your quadratic or something like that to fix it. So if you know here, the only quadratic you're gonna get is b plus a equals -2. You know your a already is 1, so then you just get b equals -3. Yeah.
Do you think it's worth doing like long division in the actual
No, not in
test?
Unless it asked for it, like where it's like necessary to the question. I'd say comparing coefficients is normally the fastest route, because you just see this and this pop out at you straight away, and this takes 5 seconds. Like, it's so much faster. So yeah, 99% of the time, just compare coefficients. Sweet. So yeah, answer should be F. Yeah, and they've done exactly that. Yeah.
Wait, excuse me, is there more physics problems left after this? Because I think we've moved on to math, haven't we?
You're right, this is very mathsy. These are very mathsy.
So maths.
Yeah, have they got the sections confused?
Yeah, this looks like the maths too.
Yeah, but
There's no physics.
this is all maths. This is all maths. They've got only maths here. What? Yeah, has the person forgotten? Sorry, it wasn't my design, this one. There's a person who's doing this seems to have forgotten physics. Okay. If you want, I'm happy to go through the rest of this PowerPoint, obviously, to see if should we just see if we can pick out any physics ones? Okay, should we go for this question then? It's got some waves in it. And yeah, and then I'll keep picking out the physics ones from here. Just obviously if this is the one that you want to focus on. Does anyone require any more time, or are you happy to? And is someone willing to share their solution?
I can do this one.
Okay.
Oh, so I knew that v is equal to f lambda. So you know that frequency is inversely proportional to wavelength. So it was just 1 over the wavelength ratio. So I got the frequency ratio is 1 times 10 to the minus 8. So that would cancel all the options from C to H. And obviously the speed would have a ratio of 1 because all speeds in the electromagnetic spectrum are 3 times 10 to the 8. And because for option B, you have microwave and radio wave, those are just right next to each other in the spectrum. So I chose A.
Yeah, good. The other slight giveaway, you are correct. They've obviously got to be far apart because it's a massive difference. But microwaves have a shorter wavelength than radio waves, but here it's saying P has a longer wavelength. So this is also impossible from that fact. So good. Yeah. Yeah, let's find then. This is this the one we did?
Yeah, it is.
Yeah, it is. Okay. What did we say? We said it was like 40 meters or something, didn't we? Yeah. I'm assuming everyone's happy with this one. They're happy with the previous explanation.
Could you go over it again, please?
Yeah. Our main thing I'll do is draw the diagram because the main thing I think through people is the pressure. So if you've got, this is your water level, and this has atmospheric pressure PA, I'm just going to call it. The water itself then contributes pressure PW is equal to rho GH. So if you're at a depth here, which we're going to call H, you then have the pressure of the atmosphere as well as the pressure of the water above you. So you get PA plus rho GH down here. Yeah. I've already forgotten the question. In a what? Appointment birdie. Okay, so you've got your ideal gas equation. Yeah, PV equals nRT at constant temperature, and obviously it's got the same amount of air, and R is a constant. That means you have PV is equal to a constant. So P1 V1 is equal to P2 V2. You've then been given 3 of those values. So P1 is equal to PA, which is just atmospheric pressure, and then 2 times 10 to the minus 3. So PA times by 2 times 10 to the minus 3 is then equal to P2, and then it's being compressed to a volume of 4 times 10 to the minus 4. And it's worth noting that this is obviously P2. So then PA times by 2 times 10 to the minus 3 over 4 times 10 to the minus 4 is well, it's basically 20 over 4, so 5. Yeah, 5 is equal to P2. P2, so that means PA plus rho GH is equal to PA. I've forgotten a factor of 5. 5, sorry, there we go. Let's just make this a little bit neater. Rho GH is equal to 4PA. Rho is 1,000, G is 10, so H is equal to 4 times, what is it, 1 times 10 to the 5 over 10,000, which is 10 to the 4. So that means you just get 4 times by 10, which is 40. Yeah?
Yeah.
Yeah, main things, this diagram just makes sure you know pressure on top and then additional pressure due to water, rho GH. And then the other key things to know this is constant. So yeah, good. That's exactly what they've done here. Okay, here we go. Here's a new one. Does anyone require any more time?
Could I have like 30 more seconds, please?
Yeah, go for it. Okay, cool. And is anyone willing to share their solution?
I got a 60 watts.
Yeah, well done. That's the same as what I got.
So you have the current in the primary over the current in the secondary equals the number of turns in the secondary over the number of turns in the primary. So you get, if you just rearrange that, you can get the current in the secondary is 0.5. Oh, sorry, 0.2, sorry.
Yeah.
And then so then you have P equals I squared R, and then you just solve for P.
Mm-hmm.
60.
Very good. Everyone happy with that? Sweet. Some more decay. Everyone happy? Is anyone willing to share a solution?
Yeah, I'll do it. I got C. So I just saw that it said there were a total of 7 particles emitted. So the only options that you could have is 4 alpha, 3 beta, 5 alpha, 2 beta, and 6 alpha, 1 beta. And I worked through all of them, and I saw that when you have 5 alpha and 2 beta, you would get Z minus 8 and A minus 20. So C.
Yeah, good. Well done. Yeah, this is a question you can quickly cancel out certain things. So because it's got to be more beta than alpha, as you said, you've got to have at least 4 alpha stages, which would mean a mass reduction of 16 at the minimum. So it could only be these 3, and then yeah, you just need to work out possible combinations. So because obviously with beta decay, you're increasing the atomic number by 1, aren't you, each time? So if you had only 4 of these, you'd have -8 here, +3, so you'd have Z -5. So this obviously isn't possible. By a similar fashion, this just doesn't work out. And yeah, exactly so that. But yeah, key thing for this is you can immediately cancel out 2 options and just focus on these 3. So yeah, well done.
Is there any faster way than just trial and error?
Not one thing that might be slightly faster is if you've got an odd number of beta decay, just as another way to cancel it out. If you had an odd number of beta decay, you'd end up with Z minus an odd number of atomic number. So like, because obviously alpha reduces it by 2 each time. So you can maybe do something with odd and even. So if you see that 4 were reduced here, in fairness, that means this is still valid, but depending on the question, it might not always be. But yeah, it's only 3 options to run through, and all you need to do is like first one you've got 60. If you have 4 decay, what is it? 16 down here, and then it will be 8 plus 3, which would be -5. So it can't be that. So you're like, okay, what's the next stage down? Lose 5, and then 2 come back up. So it'd be Z -10 plus 2. Oh, this one seems to work. And then you can try the last one as well if you want. But it doesn't take long to run through 3 options.
All right.
Yeah, main thing is just get rid of these 2 first. Oh, beautiful. We've done this one. Was everyone happy with this explanation when we went through it before lunch? Very good. Oh, no, speak up. Okay. Yeah, can we all have a go at this one? Anyone happy to share their answer? Or does anyone need any more time?
Wait, I'm sorry. I just realized I did it wrong halfway through. So if I could get like another minute, that's
Yeah,
okay.
yeah, sure. Everyone good? Anyone willing to share their answer?
Yeah, I could do it.
Yeah.
So, first of all, I worked out the total power. So I did 1800 times 10 to the 6 over 0.9 to work out the total power output, and that gave me 2 times 10 to the 9 watts. And then I knew that the gravitational potential energy over time would give you power. So I did mgh, so 150 times 10 times m over 60 is equal to 2 times 10 to the 9 watts. And then eventually I got m is equal to 8 times 10 to the 7 kilograms. And then density is mass over volume, so I rearranged and I got volume is 8 times 10 to the 4 meters cubed, so I got C.
Yeah, good. Well done. The key thing from the sounds of it, it sounds like you did it, but because you get just make sure you leave the 60 and the 150 together because they work out as a nice fraction. So again, this is a case where you don't need to multiply everything out just because you can. Sometimes like there's no point having, well, I when I did it, I ended up with like 200,000 divided by 150, which was quite an awkward number. But if you then but if you don't solve it and just leave the 60 there, it cancels out quite nicely in the end. So yeah, that's a good solution. That sounds good. Everyone happy with that?
Sorry, is it 8 times 10 to the 4, 8 times 10 to the 7? It's a bit blurry
Times
on
10
my
to the
screen.
4. This one seems quite straightforward. Is everyone happy with this? Is everyone done? Anyone willing to share the solution?
Yeah, I'll do it. So only alpha particles can change the mass number. So well, it's gone down by 32, and each alpha particle has a mass number of 4, so there must be 8 alpha particles. 8 alpha particles will change the atomic number by 16, but here it's only changed by 10, so there must be 6 beta particles.
Yeah, very good. Well done. Exactly as you said. We've been over this one. Was everyone happy with the explanation at the time?
No, can you go over it again for this one?
Yeah, okay. So it's going to be F equals BIL. If you start off with the direction first, so your current is going to come up here, around here, and then down through the rod. Down the rod here and then here. So it means the rod, which is your middle finger, sorry, the current, which is your middle finger, is pointing down, like just straight down at the table or something like that, whatever you're looking at on your laptop. The field, it's said to be going into the page. So your pointer finger goes into the page, and you should see your left thumb is now sticking to the right. So you know the directions to the right. The force is equal to BIL, as I'm sure you come across. The key thing here is that it's only the length of the current's traveling, because at the ends of the rod, there's no current moving there, so there's no force produced on the rod as a result of it, even if it's in the field. Without a current, it's not going to produce force. So the force is only produced due to the current moving through this section. So F equals BIL, force is equal to 0.5 times 0.12 times 2.4, which I can't remember exactly the number that gets you. What would be 1.2? 1.2 times 0.12, which would be 0.144, I think. Yeah, that sounds about right. What does it want to know? It has a weight of 40 newtons. If you do that's equal to mass times gravity, so divide by 10, so you get just the mass. You get 0.04. And then you've got your force, you've got your mass, and what you need is the acceleration. So just one divided by the other.
3.6.
Yeah, I'll just double check my mass. Yeah, all good.
All right, thank you.
Anyone need any more time, or are you all good? Sweet. Would anyone like to share a solution?
Yeah, sure. Sure. Oh no, G is fine.
Sure, thanks. I got D960 as my answer. So basically,
I think I got, let me double check. I got A. Oh no, fair enough. I made a mistake somewhere. Okay, sweet. Go
on. Yeah, I initially got A as well. I think I calculated the gradient, but because I realized it's non-uniform, we can't really do that. So what I did was I calculated the gradient of the constant well, the quantum gradient bit between 5 to 10 seconds. So I got that as so the gradient would be the velocity in this case. So that's 6 meters per second, and that velocity is the final velocity at the end of the non-uniform acceleration bit. So I found that the acceleration is change in velocity over time, which is 6/5, which is 1.2 meters per second squared. And force is equal to mass times acceleration, so it's 1.2 times 800, which is 960.
Yeah, good. Yeah, sorry. Well, good spot on the mistake. I'd say it's generally easy to use momentum, like changing momentum over change in time for something like this. But yeah, well done.
Okay,
yeah, so they get you. Sorry. Yeah, go on.
Sorry, I was just wondering. I also got 320. So I was just wondering, I used the speed like right after the curve had stopped becoming a curve, like it leveled out. So I used 10 and 5. So
Yeah,
why
so
yeah.
well, yeah, so because here it's going accelerating quite slowly and then it increasing is it increasing acceleration? Increase in speed. Yes, it will be increase in acceleration as well. The point is this isn't uniform, so you can't assume uniform accelerations for then like taking an average gradient of this, because the gradient here, which is actually the velocity at the end of this, is straight down to here and it kind of intercepts here. So because this is a continuation of it, this is the gradient you need to use for your final velocity at this point, because of this non-uniform acceleration, it's not an accurate gradient because you would calculate this line, whereas actually what you want is this line here.
Oh, right. Okay, that makes sense. Thank you.
Yeah. So yeah, exactly. You said final speed of 6. In fairness, they've done F equals ma. Yeah, I've done momentum, but works out to the same thing. Very good. Anyone need any more time, or you're good? Sweet. Is anyone willing to
Is it
share their
C?
answer? I got. Yeah. Well
Is
done.
it C?
Yeah. Good.
Yes.
Would you like to explain? Is it easier with this diagram, I'm guessing?
I guess if you have to, this is the wavelength of the entire wave, you can think of it as 6, which is between P and Q, plus that extra bit, so 0.8 times V. And you also know that 0.5 to wave times lambda is equal to V. And I think they've done it a bit differently here. But because in the question they tell you 0.5 is the frequency, 0.5 times lambda is equal to V. You have simultaneous equations and you can just solve for V, which is 5.
Yeah, good. Yeah, they do appear to have done it slightly differently. What have they done here? So they've got time period. So that means, yeah, they've done 2/5 of a wavelength in those 6. In not those 6, beyond it. So yeah, so it's past 0.8 over 2. If it's gone from P to Q, but it's passed here 0.8 seconds later, that means 0.4 of its wavelength traveled this distance during that time. So that means you know that the 0.6 has to be, they're saying the 0.6 is equal to, sorry, the 6 meters is the other 0.6 lambda. So therefore, 1 lambda has to equal 10 meters. And then just, yeah, lambda f is equal to 5. Everyone happy? Sweet. Yeah. Everyone happy? Anyone need any longer? Sweet. Is anyone willing to share their answer? Okay. Yeah, I'll just do this one then. So you've got unstretched. So you've got, it's basically an energy balance thing, and the potential energy initially as it's pulled down will be a half kx squared. X in this case is 0.2 meters because you've got this it's going from unstretched of 0.1 to stretched of 0.3. So you get 0.2 as your extension, so a half kx squared, and I got 0.4 joules. It's then released. This elastic potential energy will then be transferred because it's shooting upwards into kinetic plus also gravitational potential. So your gravitational potential will be mass of 0.05 times by 10 for gravity. So and then times by 0.2 because it's when it returns to its unstretched length. Which 0.5 times 10 times 0.2 is 0.1. So then the rest of it will be kinetic energy. So you've got 0.4 is equal to kinetic energy plus 0.1 for gravitational potential energy. Kinetic energy is 0.3 joules at this point then. So times by 2, divide by the mass and square root, and I ended up with G. Yeah. So I hope that makes sense.
Wait, sorry. Just one question was, for your mass, have we used the like mass they've given us? Because I thought that was the like mass you put onto the string, so I was a bit confused.
Assume you can. It's said a light spring, so assume that the mass of the spring itself is negligible, and it's a load at the end of the string of 0.05.
But like, if you take the load off, and then it's released, wouldn't? Oh right, okay. So they've kept it to the string.
Yes, everything remains attached to the
right.
spring.
Okay, that's why I was confused because I thought they took it off and then it went up. And I was
Oh
like,
no, they pulled it down with their hand and just let go, but the mass is still attached.
oh, okay, that makes sense. Thank you.
So yeah. Yeah. Anyone need any more time? Sweet. Can someone explain their answer?
Is it E?
Yes, it was.
Oh, so you know that the pressure times the volume is constant. So if the pressure is increasing by 6/5, the volume must be decreasing by 5/6. It must be 5/6 of the original. Because of density is mass over volume, just put 1 over that fraction. It's just 6/5, so it's just E.
Yeah, well done. Yeah. This one's hopefully quite an intuitive question because you're saying if you squish it more by 20%, how much more dense is it? And obviously it's more dense because it's more squished by roughly the same amount. So yeah, hopefully this one's quite intuitive. But if you're going for the exact equation, yeah, that's exactly right. Yeah, they've done the full constant thing here and everything like that. Yeah, well done. Anyone need any more time? Okay, can someone explain their answer?
I got a few one.
Yeah, go on.
So I made like a table with X, R, Y, and S, and I started off with, I know you could do it a different way, but I started off with 10,000 of each one because I thought it'd be easier if we could just have numbers. So at the end, using the half-lives, at once it got to 40, I got 19,375 of R and 17,500 of S. So the ratio of that ends up being 31/28.
Okay,
So
yeah. If that, you know what, if that works for you and you're able to do that maths off the bat without a calculator, well done, because I would not have done that. If you are going to do a method like that, for most people who aren't human calculators, I'd recommend, because you can see it's half-lives, it's going to involve factors of 2. So choose something like 16,000 or 32,000 or something like that. Because you're going to get, because then that divides quite nicely. If you're not doing it with hard numbers, I wonder if they've done it this way. Yeah, okay. So your number of R, so you're going to go 1 R at the start and 1 S at the start. So initially, obviously, this is 1. Over 40 years, X is going to undergo 4 half-lives. So that means it's going to go, X is going to be a half to the 4, which ends up as 1/16. Obviously the 15/16ths have decayed into stable nuclei R. So on top, you've got the original R atoms you had plus 15/16. Because yeah, plus 15/16, which gets you 31/16 R. And then on the bottom, it's going to undergo 2 decays because it's got a half-life of 2 years, 4 years. So only a quarter of the Y atoms are going to remain, which means 3/4 of them are now S atoms. So you've got 1 plus 3/4 on the bottom, which is 7/4. So your final thing should be like 31/16 over 7/4, which gets you your 31/28.
Sorry, I was just wondering, when they got like 1/16 like remains, why have we turned that into 31/16? How are we gone from that to that?
So I'll write it out just so it's like easier. So you have initially what was it? X goes to R and Y goes to S, and you initially have one of each. Let's go X R Y S. This will undergo 4 decays. So at the end of it, you've only got 1/16 left, which is equal to 1, 2 to the 4. Yeah, and you're happy with that stage? That's how much x is left after 40
Yeah,
years.
yeah, I got that.
Yeah. So then that means that all of everything that this is what remains. So what decayed turned into R. So that means you must have 15/16 of R after 40 years.
Yeah, I got that.
However, you also had your original 1 up here. So you get 15/16 plus 1. And
Oh,
that's
right, okay, yeah.
And that's equal to 31/16.
Yeah, that makes sense. Yeah, I forgot that there was one of each.
Yeah. And then a similar process with your y to s. Your s, you end up with 3/4 plus 1 is equal to 7.
Yeah, that makes sense. Thank you.
Very good. Then so I'll give you 1 more minute. I just need to go grab some water. Right. Everyone happy? Anyone willing to share their answer?
I'm not sure, but is it E?
That sounds about right. Oh, not quite. D. Yeah. Right. I'll run through this one quickly then.
I think I got an answer.
Do you want to go through it?
Yeah.
Brilliant.
So what I did was I just did the energy in the beaker at first. So I did 180 times 4 times 25. And because you're adding water to it, but at a lower temperature, I subtracted it with the 20 grams, so Q is equal to ml. So 20 grams multiplied by the specific latent heat of fusion, so times 300, is equal to the total mass now, which is 200 times the specific heat capacity times change in temperature, and I got 15 degrees Celsius.
I'm not. Can you describe that one more time? Because I think you did some stuff you're not supposed to do, but somehow ended up with the right answer. But I might be wrong. Can you explain that one more time?
So I had the energy in the beaker at first, so I calculated that. So 180 times 4 times 25. And then the energy in the in the other beaker, which was at 0 degrees, I subtracted it, so 20 times 300, and I just equated it with the total mass times 4 times delta T, and then I just got T is 15.
Okay, I'm very impressed you got the answer because I don't think you're allowed to do that. So first thing, this specific heat energy is not an absolute amount of energy. It's so you can't, because number one, you said times 25. Temperature, if you're measuring it as an absolute value, is always measured in Kelvin. So you'd have 293 Kelvin here if you're doing 25 degrees Celsius. And I guess you could maybe do it that way, but the way specific heat works is because you look at change in temperature. Key thing is this delta here. So what they've got here is it's got started at 25 degrees and it's drops down to the final temperature, which they've called theta. So this is the change in energy of the warm water. Then over here, you've got your latent specific heat energy, which is 20 times 300, as you did. But then it's going at that point. So the way it works is you've got your if this is the heat energy that it currently has, I know the heat equation is not for absolutes, but imagine you know the absolute temperature up here, and then this is 0. So this is no, let's do this as temperature. Sorry, this is temperature, and this is time over here. Initially, your ice is going to take time to melt, but it's going to stay at 0 degrees until it melts. And once it's melted, it's going to start increasing. Your temperature of your other one is actually going to always be going down because it's just cooling down normally, as you'd expect. And then they will meet at a final equilibrium temperature up here. So this is your theta. Yeah. So this is the temperature change that this undergoes a specific heat capacity. So you've got your M, well, in this case, so 20 grams now. So for the ice cube, you've got your latent heat from over here, which is 20 times 300. And you've got your specific heat here, which is your 20 times 4 times this change in temperature, which is just, let's call this, which is theta, which is then theta minus 0. Yeah, because we're working in degrees Celsius. Or you could do this in Kelvin. You just have to minus 293 in Kelvin. 0 is a nice number to use considering you're working in change of and not absolute. So yeah, so that's your total energy going into the ice cube. Your energy coming out of here is your 180 grams times by 4 for your specific capacity times by 25 minus theta, which is your change in temperature here. So then you equate these two, and if you can solve, and then you solve them, which is what they've done in the PowerPoint here. They've done an okay job here, but I don't like how they've got because up to here is fine, but then what I think they really should do is divide through by 80, because then you get what 9 times 25 minus theta is equal to what would be it would be 7.5 plus theta over here. And that simplifies a lot easier than this, but eventually you would then solve to get 15 degrees. So you did somehow get the right answer, which I'm quite impressed with, and you did get stuff like that, the latent heat right, but because this is a energy due to change in temperature and not absolute temperature, I'm afraid you need to use this form, and you can't just combine the mass, because you can assume the water is sitting at different temperatures and therefore not be holding the same energy up until it reaches equilibrium, when it reaches theta equals 15. Does that make sense?
Yeah.
Okay, good. Yeah, well done. Everyone else happy with that?
Sorry, really quickly, I still don't really understand why it's 25 minus theta on the left-hand side, because surely the change in t is the same on each side.
No. So imagine you've got a very hot ball of iron that's like 5,000 degrees Celsius or something ridiculous, and you take it to the North Pole, and then you let it cool down. The temperature of the North Pole on average is basically not going to change at all, because you've got a tiny metal ball and such a huge amount of North Pole.
Yeah, I get that then.
So yeah, it's the same thing in this case. Like, this is to cool down this amount, and this is to heat up this amount to reach the equilibrium. So yeah.
Yeah, okay, thank you. So
yeah, sweet. I'm assuming everything else is fine. Yeah. Everyone happy? Anyone willing to explain their answer?
I got C, which is
Yeah,
3.
good.
So I substitute that, and then you get S equals 4, U 0, A is 10, and you're trying to find T. Do S equals UT plus half AT squared, and rearrange for T to get 2 over root 5. So then you have V equals S over T, and then you have 6 root 5 over 10 over root 5, which you just rearrange and you get 3.
Yeah.
So not able to calculate 3.
Yeah, good. Well done. Yeah, exactly as you explained over here. This is your, if you use this to work out vertically, U is 0 initially, obviously vertically if it's thrown horizontally. that's exactly what the time you said, and then distance equals speed times time, because there's no acceleration horizontally, and you end up with 3. Okay, yeah. So that's the end of the physics section. What time is it? It is 3:30 now. Coming. Okay. Well, I'll go with some general advice now in case any of you want to leave and move over to, I guess it'll be biology next, the other ESAT. Not many of you, I imagine, doing physics and biology, but if you are, well done. Keep an eye on time, 40 minutes per section, and it will move on if you hit the 40 minutes. So try to be quite strict with your timings and realize if you've spent 30 seconds on a question and you don't understand it and you're not making progress, guess and move on. Because if you spend, because that's, say if it's a minute and a half per question, you then get an extra minute to spread across other questions which you do understand and will actually help you finish those and give a correct answer. But there's no point spending 5 minutes on one question at the expense of not doing 3 other questions. So yeah, keep an eye on timing. Genuinely just guess a lot. If you do want to review a question, come back to it, put a guess in first. Because if you don't have time to review, you want at least some sort of answer to have been input into the system. Flag questions to come back later. Yeah, and then lots of practice. I would say if you struggle with accuracy on your questions, maybe you make silly mistakes in your maths or something like that, focus on doing untimed papers for maybe another 2 or 3 days, and then start working on your timed ones. But there's no point doing timed papers and going really fast and making lots of mistakes when your consistency is not there. So focus on consistency for a little bit before you focus on timing. But but in about 3 days, do start doing a lot of time tests, because that gives you about a week, bit under, to practice your timings within regards to it, because that will be your biggest enemy. Yeah, does anyone have any questions particularly about the physics side?
Yeah, I've got one. Could you go over useful equations we need to know for each topic?
Okay, I'll try and remember them off the top of my head. In fact, the best place to do this is probably the ESAT website, if there's a specification.
Hi, sorry, this is a little unrelated, but I know that the physics and math tutor, they do a whole equations that are useful thing. So that's what I'm using. So that might be helpful. I don't know. Okay, bye.
Thank you.
Revision past papers. Do you know roughly?
Yeah, it's under the anger revision session.
Yeah. Do they have an ESAT yet? No, they've got an anger though. Okay, yeah, your anger, your ones used for the anger will probably be almost identical for the ones used for the ESAT. So yeah, this sheet looks good. Series resistance, parallel, potential divider, power, definitions. All of these look quite good. Oh, you have to know.
Yeah, I haven't actually seen the slits in an angle.
I don't remember the slit equation. I haven't seen that pop up yet. It's one that you might need to use, but
I think it says on the ESAT specification, it lists out some of the equations. You have to scroll through and look for them, but it has, I think, the equations you need.
What is it? Overview? Is it just under preparation materials, do we reckon?
Yeah, I think either the how to prepare or the test format section at the top.
How? No, let's go. ESAT test specification. Assumed knowledge. I'm just going to see if there's anything where they can do equations, surds, ratios, algebra, reciprocal functions, so quadratic formula they may mention specifically, Pythagoras, all the basics, circle theorems, stats, probability. Physics. Okay. So definition of current, definition of resistance. It does mention properties of like LDRs and negative temperature coefficients, thermistors. So as temperature increases, resistance will decrease. LDRs, I can't remember, is it light increase? I can't remember which way around LDRs or if they're positive or negative coefficient. But yeah, remember that. Voltage is equal to definitions of voltage, definitions of energy. You'll need F equals BIL, as we've seen. Transformer ratios, kinematics. There's nothing here that seems too unexpected. Energy in a spring. Yeah, you should know force is equal to rate of change in momentum, not just F equals ma. All of this looks fairly normal. Specific heat capacity. Yeah. What I'll do is I'll put this in the chat and then I'll put that one in the chat and then I'll also put yeah, I've put both the maths and physics tutor thing in the chat and this document that goes through all of this. There will be weird functions that one that got me the other day is a half a b sine c. I forgot that exists and it made the question very difficult without it. But yeah, a half a b sine c is a good one to remember. Yeah, I'm afraid the best way to know that is number one, go through the specification, and number two, do a ton of practice questions. Make sure if there's any formulas which you forget or you're like, oh, I didn't remember that. Remember those ones. So yeah. Any other general questions, especially for physics? Sweet. Should we take a 15-minute break or something then? We're around it. Yeah, 15 minutes if we return at 10 to. And then we'll go through maths 2 after that, yeah? If you just mute yourselves, cameras off, and then I'll see you in about 17 minutes. Hello. Is everyone good to go again? Just beautiful. Maths 2 is starting now, just in case anyone wants to know. But yeah, I'll start Maths 2 now. It's about 10 to 3. Sweet. So Maths 2. It is another 40 minutes, another 27 questions, multiple choice once again. Not everyone has to do this one though, however. So engineers do have to do it because engineers you have to do Maths 1, Maths 2, and physics. But nat skis, you may or may not choose to do it. You might do Maths 1, physics, and chemistry if that's what you're more comfortable with, or but you could also do the same as the engineers or add biology in there if you're feeling quirky. Not many people do both Maths 2 and biology though. It's quite a strange mix, but if you want to, you're perfectly welcome to as a nat ski. It shouldn't be much harder than year 12 maths because I think that's kind of where they shoot like AS level maths because that's kind of where they assume you've studied up to. I have seen how there's stuff like sequences and that, which I'm pretty certain are like a year 13 topic, like geometric and arithmetic sequences and series and sums of them. So there may be some relatively easy year 13 topics in it. Stuff like sequences and series, when I have seen them do stuff like the sums, they have given the sum of the series equation for you. So I don't think you need to remember that generally. Like the arithmetic series sum or the geometric series sum. However, you do need to remember the general form of stuff like the sequence equations. So was it for a linear arithmetic, it's a plus n minus 1d, and then for geometric, it's a r to the n minus 1. You do need to remember those general forms. Let's start off with this question. Anyone still going, or are we happy to have answers? Anyone willing to share?
I got D66.
Yeah, good. Well done.
So an interior angle is going to be 180 n minus 2 over n, where n is 5. So the interior angle is 108. Obviously, USR is going to be 60. So UST will be 48. And it's an isosceles triangle that SU is the same as ST. And so so you just do 180 minus 48 divided by 2, which gives you 66.
Very good. Well done.
How do you know ST is the same as SU?
Because so, oh, sorry, go on.
Okay, so it's an equilateral triangle. So SU is obviously going to be the same as SR, and SR
yeah,
regular
I see it.
pentagon.
Yeah, thanks.
Yeah, good. Very good. They've said the exact same thing. The only different thing they've done is for the interior angle. They've done, you did n minus 2 times 180 over n. They just did, this angle is 360 over n. So that means this angle here is 72, which means the interior angle will be 108. It's the only difference they've done. Whichever equation you prefer to remember. Yeah. Everyone good, or does anyone need more time?
Is it D?
It is indeed. Very good. Yeah. Go on. Do you want to
Sure.
expand?
You can use the formula where the diagonals multiplied divided by 2 is the area. So you just have 3x plus 2 multiplied by 8 minus 2x is 22. And then from there, you just get a quadratic, which you can solve for the two values of x. You plug them back into the PR to get the two possible lengths.
Yeah, good. Any issues with that? Everyone happy? The only slightly weird thing to remember is you have to remember that the area of a rhombus, which I never have bothered, so that'd be the only thing that might trip you up. But yeah, as long as you can remember that, it's just nice, easy to solve quadratic. Very good. Yeah, there's the working if you need to see it. Okay. Yeah. Right. What is the the only other thing to mention is obviously if you have a third, then in fairness you could have a third. Yeah, whatever works. This one. Everyone good, or does anyone need any more time? Sweet. Any volunteers?
Yeah, I got 6.4 as my answer.
Yeah, very good.
So I did it a different way. So I said let angle PRQ equals theta.
Yeah.
And I first calculated PR, and this is a Pythagorean triplet, so just 5.
Mm-hmm.
And then if PRQ is theta, that means RQS must also equal theta. And then using the cosine formula, I just rearranged to find in terms of QS. So cos theta in this case is 4/5. So I said cos theta is equal to 4 squared plus QS squared minus 4 squared over 2 times 4 times QS. And then I ended up getting 32x is equal to 5x squared, where x is just QS. And then when I found out for x, I got 6.4.
Yeah, good. Okay, yeah, I think you did it almost identical to me. Slightly different. You noticed something. Yeah, I think you did almost identical to me. What did they do? They did QRX, which is this one here, is equal to 90 minus theta. What have they called theta? They've said this is theta. Sine theta. Oh no, they've called this theta. Because they've got sine theta equals to 4/5. X be the midpoint of QS. 4 times sine theta. So that's this height here. Oh no, that's this right there. Yeah, okay. Yeah, they've done it similar but different. I think basically they've done sine theta whereas you did cos theta. Both are equally valid in this case. I think actually it's even, yeah. Yeah, well done. Anyone willing to share their answer?
I got 1/8.
Yeah, very good.
So the probability of getting 3 is just a half, because there's 4 sets of 3.
Mhm.
The probability of getting 2 is just an eighth. So if you multiply them together, you get a 16th. But obviously, you can get a 3 and then a 2, or a 2 and then a 3. So you just multiply by 2 and then you get an eighth.
Yeah, very good. Yeah, that's exactly what it is. Anyone need any more time? Very good. Anyone willing to share a solution?
Is it B?
I also got B. Yes.
Yeah.
So go on.
So I did the number of boots is inversely proportional to t cubed. So I set 250 is equal to k over 8 cubed. So I got k is 250 times 8 to the power 3. And I almost got tripped up because it did say it was 700%. So I just did 250 times 7, but you had to add that back to 250. So that would give you 2000. So 2000 is equal to k over t cubed, and I solved, so I got t cubed is equal to 64, so I got t as 4.
Very good. You did a lot of mental maths in that if you actually solved each thing. Yeah, well done. You're not using the calculator, are you?
No.
Oh, well done. You got very good mental arithmetic. Yeah, exactly right. The main thing I did different is I didn't bother with too many numbers. As you say, it's 700% more, so it means you've got a total of 800% now. So because you've increased the number of boots by 8 and it's proportional to 1 over t cubed, that means you must have had to half t. So if you've halved the temperature from 8, you get 4. So that's how I did it. And then you don't need to do, 250 times 8 cubed or anything like that.
Why do you half the temperature?
Because it's if you've got T1 is equal to K, sorry, let's do this the other way around. If you've got boots 1 is equal to K over T1, and you've now got plus 700% B, or you got 7B plus B because it's 700% more, that's equal to 8B1, which is then equal to K over T2. So then 8 K over T1, just substituting this into here, is equal to K over T2. Obviously, these cancel, and therefore you see that T T2 over T1 is equal to 1 over 8. Yeah. Sorry, this should have a cubed. This should be cubed. This is cubed, this is cubed, and this is all cubed, and therefore T2 is equal to cube root of 1 over 8 times by T1, which is equal to T1 over 2. Yeah.
Okay. Yeah.
And then you don't need to worry about this 8 cubed times 250 because 64 times 8 I do not know off the top of my head, yet alone times 250. So yeah, it just saves you that little extra step. Yeah, they've solved it. Okay. Yeah, it doesn't look too bad number, but yeah, if you don't want to figure that out, just do what I did.
Hi, wait, sorry. Could we just go to the solution for just a second? The one.
What, my one or this one?
Your solution, please.
Yeah, sure. So, original number of boots, which in this case is 250, and then they tell you it's 8 degrees Celsius. And then this is just inversely proportional cubic relationship. So B1 is equal to K over T1 cubed.
Oh, okay,
it tells you, pardon?
Yeah, that makes sense. Yeah.
Yeah. It then increases by 700%, which means you need an extra 7B. So you get a total of 8B. And this is your B2 now, 8. So this new number of boots is equal to K over new temperature cubed. If you substitute this equation into here, you get 8 times K over T1 cubed is equal to K over T2 cubed. Multiply T2 across, divide by 8, like cross multiply basically, and you get T2 over T1 cubed is equal to 1 over 8. Yeah.
Yeah, that makes sense. Yeah. Thank you.
And then are you happy with the rest of it?
Yeah. Thank
Very
you.
good. Yeah, well done. Yeah, and then obviously t over 2 is just 4. Yeah, 8 over 2 is 4. I mean, yeah. Oh, I misread this question. Everyone good? Anyone want to give their answer?
I got. Oh, sorry.
Yeah, sure. So I said the original price was X, and then it's reduced by 25%, so it becomes 3/4 of X. And then this customer increases it by 25%, so that's the same as timesing by 1.25. So 3/4 X times 5 over 4 is the same as 15 over 16X. So the difference between X and 15 over 16X is 1/16 of X. So 1/16 of X is equal to £15, so X is £240.
Yeah, really good. Well done. I misread this. I thought he said the final price was £15, so I misread this. But yeah, it just shows be careful when reading the question. Make sure you do the right thing, because I just had to spend an extra few seconds correcting myself, which you don't have too much time of. Yeah, exactly as you've done. Well done.
I'm so sorry. I just have to quickly pop out. Is that okay?
Yeah, of course. Yeah.
Thanks.
If you're going to another room, then leave. But if you're just, walking away from your laptop, probably just mute yourself and turn your video off.
Yeah, I'm just walking away from my laptop for like 5
Yeah.
seconds. Okay. Bye.
Everyone good? Anyone want to share their answer?
I got D is my answer.
Yeah, good. Yeah, this is the image for anyone who couldn't quite picture it. Not quite. Imagine it rotated slightly because obviously it's like what 1 1 and then 3 5 would be up here, but this is essentially the image. Do you want to explain your solution?
Sure. So in this case, I mean, there are two possible cases. Either 1 1 and 3 5 are one of the edges of the square, or 1 1 and 3 5 are one of the diagonals of the square. In order for the lengths to be minimized, so I just calculated the distance between the two. So I just first got the distance as 8 root 5, and that would probably be the side length of a square, of the square with the maximum possible length. Or the other option is if that's the diagonal, that means two side lengths must be equal, so 2x squared, where x is a side length, is equal to 20. So x is equal to root 10, so one of the side lengths is root 10. And we're asked for the difference in perimeter, so it's 4 times 2 root 5, which is 8 root 5, minus 4 root 10, which is the smaller one. And then if you factorize 4 root 5 out, you should get 2 minus root 2 as the answer.
Yeah, well done. Very good. Yeah, I think that's it. Yeah, very good. That's Is everyone done?
Can I get a bit more time?
Yeah, sure. Anyone willing to share their solution?
I could.
Yeah, go on. What'd you get?
So, since since it meets at 2 points, I equated x squared minus 4x plus 5 to the 2x plus c. So if you move everything to the same side, you get x squared minus 6x, add 5, take away c. So next I said that since they intersect at the x coordinates p and q, I said you can write the equation that we've got as x minus p times x minus q. So that means that pq is equal to 5 take away c if you expand the bracket, and minus p minus q is equal to minus 6. And we're told to work out, sorry, we're told that q minus p is equal to 8. So then I get that q is equal to 7 and p equals minus 1 because they're simultaneous equations. Subbing this in into pq equals 5 minus c, minus 7 is equal to 5 minus c, so c is equal to 12. So F.
Yeah, very good. Oh, I realized I actually had a negative left over somewhere.
Sorry, could you repeat how you did that last step? So you got p equals 7 and q is minus 1. So how did you get c again?
So I said that since I had the original quadratic, which is x squared minus 6x add 5 minus c. And if you factorize that, you get x minus p times x minus q. So therefore, if you expand that bracket, pq is equal to 5 minus c. So minus 7 is equal to 5 minus c. So then you can
Yeah,
rearrange.
thank you.
Perfect. Yeah, that's exactly the way I did it. You did it almost line for line what I did. However, they did a different way apparently according to this. So when you use the quadratic formula, you obviously get minus b squared plus minus, and then this root b squared minus 4ac over 2 is going to be the difference of the two terms. So yeah, like if you substitute this in, and considering the difference you've been given is 8, that means yeah, plus 2 times plus minus this over 2, which means just this thing here basically is equal to 8. And yeah, you get 12 out of that as well. Honestly, either way is valid. This one might be slightly faster in fairness than the way me and you did it, but whether works for you, whatever most intuitive. Especially if you see one before the other. Don't waste time thinking for the longest route, particularly unless you're going to take massively longer. But if you see one route and it's only going to take you 2 seconds longer, it's better to do that than to think, is there a better way to do this for 20 seconds and then do the faster way? So yeah, well done. Everyone good for this? Anyone willing to share their answer? fair enough. Yeah, you can do it either by thinking about it logically. So, if 1 is equal to X miles, then M miles must be over 1 over X. Sorry, M over X kilometers. Yeah, and you can think of it doing it kind of that way. And you just work through each of these little instructions given you. Which is the way I did it. However, admittedly, their way makes a little bit more sense, where you just basically do unit conversion. So pound over pence times, well, you got your pound is equal to your pound over your pence times your pence over your litre times litre over kilometre. As you can see, cancelling down. Pound per pence is 1 over 100. Pence per litre you were given as P. Litres per kilometre. Oh, sorry, you were given what you were given is 1 over F, because 1 litre takes you F kilometres. So that means litres per kilometre is 1 over F. Kilometres per mile is 1 over X, and then miles is M. And you can just see these all kind of cancel down to you're left with just pounds. And then your equivalent formula is this. Yeah? Which was option H, just for anyone who didn't know. Yeah. Everyone happy with that? Let's move on. Okay. Everyone good? Anyone need any more time? All right. Any
A little more
volunteers?
time, please.
Yeah, sure. Everyone good? Would anyone like to share their answer?
I got D.
Pardon?
I got D.
D? Yeah.
I got C.
I got D.
D.
Oh.
Yeah.
Yeah. So someone who got D like to go ahead?
So you have your two equations. So area of a sector is half r squared theta. So you have half r squared theta equals 10 pi, and half r squared theta plus pi over 20 equals 25 over 2 pi. If you make r squared the subject of both of them and equate them together, you can get, and you work your way down, you can get theta equals pi over 5. You plug that back into the original equation, you can get the radius is equal to 10. The length of an arc is just r theta, and it's asking for the arc length of t. So you just do the radius, which is 10, times by theta, which is pi over 5, plus pi over 20. And I think that's where the person who said C went wrong. They didn't add the pi over 20, because that's happened to me first. And then that gives you 5 over 2 pi.
Yeah, you're right. Because it's asking for like sector T, right? Not sector S. Yeah.
That's happened to me.
Yeah, very good. Yeah, I think you're right. What they do, and are squared. Okay, they did it the same approach I did. But yeah, I think you're equating R is quite a good idea because it cancels out a lot of like this stuff. So yeah, I think you're equating R is quite a smart idea. Yeah. Oh, sorry. Very good. Next one. This is quite a short one, I imagine. People done? Does anyone need more time? No? Anyone able to volunteer a solution?
C.
Yeah. Well done. Okay. And yeah, would you like to go to it?
Okay. The radius of the circle is √5, and then the distance to the point is 5√3 from the outer rim. So if you calculate the hypotenuse, it's √80, which is 4√5, and then you subtract √5, which is the radius, which gives you the shortest distance.
What? I'll subtract this. Yeah. Yeah.
Yeah. So like, to the like the radius is √5, then p to that outer point there is 5√3. Yeah. And so then if you work out the hypotenuse is √80, which is 4√5, and then 4√5 minus the radius is 3√5.
Yeah, very good.
Hi, sorry, I was just confused. Why did we take √5 away?
Because it's asking for the shortest distance to the circle, so it wants to know what's this distance from here to here. It's not asking for this whole thing, so you're taking away the radius just to get to here.
Okay, that makes sense. Yeah, thank you.
Yeah, and well, notice I admittedly got E because I did the wrong answer because I forgot to take away the radius and I forgot this was rooted already. So I just did 75 plus 25. But all I'm trying to say is be careful, because it's just silly mistakes like that where you don't read it properly or you forget little numbers that and they will put those sort of answers there which you think you're right and then you're just not. So yeah, just be careful, but well done for getting that. This one I noticed you. I hope you noticed the trick. So does anyone want to say what the answer is?
Is it 0?
0.
Yeah, exactly. It's difference of two squares. So you can take the to the power 5 out. So if you have like all in one bracket, 1 minus 2x, 1 plus 2x, all to the 5. But then this expands and you get 1 minus 4x squared, no, to the 5. Like what 1 minus 4x squared to the 5. Yeah, exactly here, as you do here. There's only going to be even powers. You're going to get like x squared, x to the 4, x to the 6, up to x to the 10, but you're never going to get an odd coefficient such as x to the 3. So the coefficient of x cubed is 0. Yeah. So rather than trying to expand both of these through binomial theorem or whatever else you're trying to do, just notice difference of two squares and then solve. Yeah. Oh, this one doesn't have an answer. Very good. Everyone done? Anyone need any more time? Sweet. Anyone wants to share their answer?
I got A.
Yeah, very good. And how do you do it?
So you have the f dash x is ax plus the gx. So you would have you basically substitute that into the integral. So you have the integration between 4 and 2 of f dash x minus ax, and the integration of f dash x is just fx. So fx between 4 and 2, and in the second part you can see that f of 4 minus f of 2 is 18. So you can put 18 minus the integration of ax between 4 and 2. So that would be ax squared over 2 between 4 and 2 is equal to 12. And then you should get 18 minus 6a is equal to 12. So 6 is equal to 6a, therefore a is 1.
Yeah, very good. Well done.
Wait, sorry, I didn't get that.
It's probably easier if I write this one out. Just because it is a long one. So what have you got? You got f of x is equal to ax plus g of x, yeah? So that means f of x, and I'm just going to do it between limits of a and b for now, is equal to a over 2x squared plus the integral of g of x, and let's put the limits here, a, b, dx. Yeah, so just if you integrate it, you get this form. It then asks, what is it? You get told between, it then asks these two things. So integral of gx between these limits is 12, and this equation is 18. So if I'm just slightly rearrange that, so if I say f of 4 minus f of 2 is equal to 18, you can see this is essentially what happens as two limits, because this equation up here is equal to f of a minus f of b. Yeah. So if you substitute a is 4 and b is 2, then you get the integration of a over 2 x squared 4 2 plus this integral of 4 to g of x is equal to 18. Yeah. Everyone
Sorry,
happy with this?
Yeah, that
Yeah,
does make
everyone's
sense,
happy with this. Very good. This you've been told over here is equal to 12. This 4 between the limits of 4 and 2. So if you substitute that in, you then get, and I'm also going to substitute here in there. So you get a over 2 16 minus 4, just when you substitute x in, plus 12 is equal to 18. That's not 112, that's just 12. So yeah, if you, this then becomes 12, 12 divided by 2 is 6, so 6a equals 6, a is equal to 1. Yeah?
Yeah, that makes sense. Thank you.
Very good. Everyone done? Anyone willing to share their answer?
Oh, is it C by any chance?
Yes, it is.
Yeah, I actually found this one quite difficult, but I think if you rewrite y in terms of x and then write an equation for the surface area of the cuboid, you want to differentiate it to make it 0, and you can work out x. You work out the value of each side, and then you multiply the two biggest numbers. So in this case, it would be 2x and y, 8 and 12s, which could you 96.
Yeah, very good. Is there anyone that didn't get this and would like me to run through it like written and you can see it?
Yeah. I would like that, please.
Yeah. So we've got 2x squared y is okay. So you got 2x squared y is equal to 576, I believe. And then surface area is at a maximum. So your surface area is equal to 2 because you've got obviously 2 of each face, and you're going to have each combination of x, y, and 2x. So you're going to have 2xy plus 2x squared plus xy. Yeah, so that's your total surface area. I'll call it A, actually. That's just what's like easier. If you do, you then be told this has a maximum. Also, sorry, very quickly, y is equal to 576 over x squared, 2x squared, which is 288 over x squared. Yeah. If you want the maximum surface area, obviously you have to differentiate and set to 0. But just before we do that, sorry, my brain's jumping a few steps, but I'm hoping you're still making sense of it. The area, if you simplify this, is going to be equal to 3xy, but we're going to substitute this in for y. So we're going to do 288 over x squared plus 2x squared. All multiplied by 2. Where did I get 3 from? I have no idea where I got 3 from. That should be. Oh no, yeah, it is 3. Sorry, it's the end of the day. My brain is really struggling for me right now. That plus that. Yes, that is fine. And then multiply by 2. Which is then equal to 2 times 6 times 2, 8. I chose not to x. No, sorry, over x. Plus 2x. Does that make sense up until there? I've just given a in terms of x. Sorry, I know I've been speaking nonsense, but all happy with that?
Wait, sorry, haven't you already expanded out the like 6 times 288? Is that not already times by the 2?
No,
Oh wait.
That means this should be this, and this should disappear. You are correct. Well done. Yeah, well done. So yeah, 6 times 288 over x plus 4x squared. Yeah, that is my original working. Yeah, that looks familiar. So then dA over dx, because you're trying to maximize it. This technically could minimize it as well, but we're going to say equal to 0. Differentiate this, then becomes, it's because it's to the x to the minus 1, it becomes minus, and then over x squared. So you can have minus 6 times 288 over x squared, and then this just becomes plus 8x. If you multiply by x squared on top and bottom, you get 8x cubed minus 6 times 288 equals 0. I know it's supposed to be over x squared, but if you multiply 0 by x, if you take the x squared over to the other side, it disappears. Yeah. So yeah, then divide by 8. Well, in my case, I divide by 4 first because I saw that more easily. So I had 2x cubed minus 6 times 72. When you divide by 4, yes, equals 0. X cubed minus 3 times 72 equals x cubed minus 216 equals 0. At this point, I hope you know your cubics. That's the only way I can really see to do this, but you get x equals 6. Yeah. You then want your largest surface area, which I'm sure if you can see, because you've then got x equals 6, 2x is equal to 12, and y is equal to 288 over 36, which is then equal to 8, looking hopeful.
Yeah, that makes sense, but I feel like I wouldn't be able to do that in a minute and 30 seconds.
Yeah, that's the thing with the ESAT. You can't, like, I don't know how you're supposed to do this in a minute. So that's why I say, like, if you're running with this, in fairness, because like seeing what you're supposed to do is quite easy, because you have a volume, you have a substitution, and you have a surface area, and then it's just running through the maths. Particularly, you could cut out a few steps here if you're better at division than I am. I'm not very good at seeing factors and numbers, but you could jump straight from here to here and then solve. But yeah, you then end up with y is 8. Yeah, and then you want the biggest surface area side, and you can see the biggest surface area is going to be 12 times 8 out of the three possible combinations. So you got 12 times 8 is equal to 96, or 2xy equals 96, and that's your answer.
That makes sense. Yeah, no, it makes sense. It's just time.
Yeah, I'm afraid I don't have a solution to get faster at questions like that, other than just be better, which isn't necessarily the best advice. But yeah, I'm afraid be better is all I can give you for this one. Another possibility is no, there's not even any easy way to cancel down what it's going to be. Because I'm guessing you can assume it's going to be some sort of integer, but that's a gross assumption and only cancels out 2 answers, and the others are quite reasonable to predict. 72 you get if you do, what is it, 2x times x, if you multiply the wrong numbers. So yeah, sorry about that. Do they do a better way? Same as me. They skipped a stage there just to get to there. But then substituted in that. Yeah. Yeah, I'm afraid I don't see an easier way. Even here, they look like they've skipped steps where they're forming, like, if you want to write out what the surface area is and stuff, which you probably need to. I doubt most people go from the equation I wrote straight to that without some sort of visualization. So, yeah. Everyone done? Anyone need any more time?
No,
Wait, sorry, was that more time or you're done?
please. A little longer, please.
Yeah, sure. Everyone good? Right. Anyone willing to run through their solution?
I got
D.
D.
Yeah,
Got
very
D.
good. Everyone wants to talk us through. I don't know if this makes it easier.
Oh, I did a different way to that.
Did
So
you use tan by any chance?
I used because tan squared x equals sec squared x minus 1.
Yeah, fair.
Yeah, I did that and then I just solved for tan x.
Yeah. I've never been a big fan of that formula, but also because then you end up with a sec, what is it, tan squared and a sec over here, which just
But I just
it's just a
converted
little bit
sec
more
into one
fiddly,
of
I
the
think, because it's
cos.
not sec squared. But whatever works for you. If it works, it works. Well done. But yeah, does anyone want to do this method? Want to run through it quickly?
Yeah, sure. So I did 7 cos x plus sine square x over cos x is equal to 5. Then I times both sides by cos x. So I got 7 cos x squared plus sine squared x is equal to 5 cos x. And then I used the fact that sine square x plus cos square x is equal to 1. So that led me to 6 cos square x minus 5 cos x plus 1 is equal to 0. And then I got 2 solutions for cos x. So I got 1 over 3 and 1 over 2. Then I drew out a triangle where it's adjacent over hypotenuse. So then I worked out the opposite side. So I got 2 root 2 and root 3. And then tan theta is just opposite over adjacent. So root 2 over 1, 2 root 2 over 1 and root 3 over 1. So 2 root 2 and root 3.
Yeah, very good. Well done. Yeah, nice. I need just a little 5-minute break. So can we just pause there? I'll be back very soon. But if you guys also want a 5-minute break, we're nearly at the end, I imagine. Actually, you know what? Screw it. Let's finish this. Because what is it? One more question. Yeah. Okay. Let's do this one question. Anyone need any more time? Okay, great. Is someone willing to share a solution?
I got E.
Yeah, same. Very good. Do you want to explain?
Yeah, sure. So I basically split the triangle. So I got the base as 4, and the hypotenuse as 8, and then you work out the height. So I got 4√3 for the height, and because the center for the triangle is 2/3 from the way up, so I got 8√3/3. Squared times pi is 64/3 pi, and then I worked out the area of the triangle, so half base times height, which gave me 16√3, and then I just subtracted it and I got E.
Yeah, well done. Very good. Is everyone happy with that explanation, or would anyone like a diagram and stuff explains that? Very good. Yeah, exactly. You said area of the equilateral triangle, you get 16√3. Oh, they did the sine rule 8 times 8 times to find angles and then get R.
Yeah, I did that.
Where did they do that? Oh, okay, Fairs. Yeah, okay, that makes sense. I kept splitting, did Pythagoras, but yeah, sine rule's equally valid. I need to remember my sine rules better. And then shaded area is finally this minus this, which rearranges to this. Sweet. That's all of Maths 2 done. Does anyone have any questions regarding Maths 2 in particular? And then any other general questions at the end?
Obviously, the exam is extremely like time pressured. So how would you go around that? Because I don't think it's like possible to every single question.
It's not basically.
Yeah.
Like when I did the ENGA, which is also a minute and a half per question, it's 40 questions in an hour. I think I did 30. I did like between 32 to 36 of them, somewhere in that range.
Yeah.
But I remember feeling very proud of myself because when I'd done like practice ENGAs and stuff, I had barely been able to do like 30. So I think I got a bit lucky and just had a good day. If anyone manages to do 40, it's insane. So yeah, you probably will have to guess some. I think the general rule is if you realize a question is taking you too long, and particularly if you're not making progress, move on.
Okay.
If you look at a question and you don't understand what to do and you just sit there for 30 seconds, move on. If you are doing a long question but you're making good progress, like that one, it just takes time. And particularly I forgot the sine rule. So I kind of like I had to split the well, if you had the triangle like this and you wanted this point R for the radius, I had to split this into 30.
Yeah.
This was 8, and then bisect this, so I got 4 here, and then it was what cos of 30 equals 4 over R, which is equal to √3/2. So that's how I got R. But just stuff like that, it just takes extra time. So if you're not particularly if you're not making progress, just move on, flag it. But as I said, if you're going to flag it, take a guess first. just because if you don't have time to review it or the test shuts off at the end, because I think it just abrupt stop at the end of 40 minutes and you can't edit anything else. If that happens, you want to make sure at least some answer was input there as a guess. So if you're gonna take a guess, move on. If you have time, come back to it.
All right, thanks.
I was just wondering that I've seen like a lot of the practice questions on the Exam Ninja website have like capacitors and stuff on it. And my school's only just started teaching me that, and I was like, is that another thing that's off the spec then? Because I feel like the ESAT spec wasn't like clear if it was going to be there or not.
It is not appearing at all in this document.
Right, okay.
Electrical circuits. I'm not seeing capacitance appear anywhere. I don't think you're due to know capacitors.
Okay.
Yeah, I think you'll be okay without them.
Okay, that's fine. Thank you.
Any other questions? Anything anyone wants to know? We're due to finish in 10 minutes, but we can finish early if you want. Just anyone, any questions on anything we've covered today, any general advice for the exam, just throw it out there. Okay, fair enough.
I had one
I
question.
actually had a question. Oh, sorry, you go first. Oh,
Thanks. I was wondering that for Maths 2, would that be, so on average, would that be like a lower score than Maths 1 and Physics? So would that be normal?
I would assume it would be definitely lower than Maths 1, just because it will be harder questions. I think Maths 2 is designed more for engineers and phys nat skis, whereas Maths 1 obviously everyone does it, including the bio nat skis. So I imagine that you will get a lower score in Maths 2 than you would Maths 1. In regards to physics, I imagine it depends on your individual strengths. If you're someone who's really good at physics, you do better in physics. If you really like the maths, you'll do better at maths.
All right, thank you.
Sorry, there were some other questions that popped up and then
no,
everyone...
you answered the question.
Oh,
you answered the question.
Okay. Sweet. Anyone else? Anyone all good? Just if before you go, I forgot to check. I'm supposed to give you a form, which I will post in the chat in a sec. Can everyone see that form that's just appeared in the chat? If you fill in that form, I'll be around for another like 5 minutes or something if anyone wants to ask any questions. But yeah, after that you're free to leave. There were no questions that went unanswered, were there? No, I did them during lunch, didn't I? So yeah, fill in the form and then you're free to leave. But yeah, thank you all for coming. I hope this was helpful. And yeah, I wish you guys all the best of luck in your upcoming ESAT.
Do you know the booster course, whatever it is, next week? Do you know what that's about?
I'm afraid not. I'm not involved in that. So yeah, I'm afraid I don't know what's in that. I would just see what you can find out from it.
All right, thanks.
Thank you.
No worries.
Thanks.
Thanks a lot.
The recording should be I'm not the one distributing it, but I'll stop the recording now. and it should get sent out to you guys fairly soon.